End of another section, and all I can think to say is nice work. In this section, you have taken a big stride forward in your understanding of React. Let's look at a quick recap of what we've learned. First, and probably most importantly, we have talked about props in React. Props are one of the most fundamental topics in React, and they really make it so you can write more composable code. You can see in both of our projects, we have elements on our page that are essentially reused, both in the Airbnb experiences cards here and the travel journal cards here. Now that you know the concept of props and reusing components with different data, I guarantee as you start paying attention to the websites and web apps that you use online, you're going to see this concept everywhere. Then what props really enables us to do is use data to drive the code and map over it in order to create the website that we're trying to create. Now, although there's only 2 topics here in this recap, those topics are extraordinarily important as we move forward. As always, you should be extremely proud of what you have worked on so far. So I highly recommend that you go over to the Discord server. If you click on the screenshot, it will take you to the Today I Did channel. And even if you don't feel like sharing your code or a screenshot, at least post a message in there that tells people that you have now completed section 2 of the Introduction to React course. Also, this is a very natural time to take a break from your computer. If you've been working on this for quite a while, make sure that you stand up and move around a bit, get something to eat or drink. Your brain does need some time to digest all of this new information that you've been learning, so even if you need to come back tomorrow, that's completely okay. And then whenever you're ready, I will see you in the next section. You have done an amazing job so far, and now we have arrived at probably the most exciting section in this whole course, and that is how we can create interactive web apps in React. Until now, we have basically just been recreating static websites in React. And of course, along the way, we've also learned how we can use props to create reusable components in React. But really, so far, that's only allowed us to create reusable parts of what is still considered a static website. If you think of the Airbnb experiences clone that we just finished building, we left it off in a state that really still didn't allow for any kind of interactivity with the user. On the real Airbnb website, a user can click into those experiences, they can save them to their favorites, and then of course they can actually book that experience and pay for it. So that lets us know that there is so much more that we get to do with React. And that's where you've arrived in this section. To help us better understand what I'm talking about, let's take a look at the difference between static websites and dynamic web apps. The static web pages that we've been doing so far, they're really read-only. They don't allow for any kind of changes to the data. And that's probably the defining attribute of a static web page. Especially in the early days of the web, but still pretty common today, you'll find static web pages like a blog, a news site, recipe sites, and a bunch of others that really don't allow you to change any data, but rather just to read or consume the content that exists on the page. In this section, we are going to be learning how we can use React to also create dynamic web applications. And the defining attributes of these web applications is that they are both read and write. In other words, the user has the ability to change the data that drives the app. As such, they tend to be highly interactive, and instead of displaying the same content for every user, they will display your specific data. And these kinds of web apps drive entire businesses. If you think of, for example, your bank website, or the real version of Airbnb. And this list goes on and on if you think of social media websites or online games or anything that is highly interactive and displays data that's specific to you as the user. You could say they all exist on a tier sort of above a static website because of the amount of interactivity they have. Of course, we're not quite ready to recreate an entire site like Airbnb, so we'll be using this meme generator project to drive forward the curriculum in this section. In this project, when the app first loads, it's going to reach out to an API and get 100 of the most popular meme images at that time, and give the user the ability to enter the text that shows up on top, the text that shows up on bottom, and also to click a button to randomly choose a new meme image. Just like before, you can click the screenshot here to go to the Figma design file. And again, I recommend you copy it to your drafts. So if you click the arrow at the top, duplicate to your drafts, and choose this option, it will put an editable copy in your own Figma drafts that you can use as reference. In order to build this project, we're going to be learning about event listeners and how we can add that dynamic interactive aspect to our web application. We're going to spend a lot of time learning about something called state. We'll officially cover conditional rendering, which you've already had a few sneak peeks at so far. We'll talk about forms and how we can gather data from the user, and we'll learn about side effects and how we can manage side effects in React. Once again, we'll be starting off by building some of the static components of our page here. So if you already feel like you're 100% good on CSS in React, you can skip the first couple lessons where we're mostly just doing some setup and styling for this app. However, I do encourage you once again, if you haven't been practicing your CSS inside of your React, or honestly, even if you're feeling a little bit hesitant on CSS in general, not specific to React, then don't skip those screencasts. Go through those lessons, do the challenges, and that will be a great way to get some additional practice on those topics and set you up for success with the rest of this project. So click the screenshot to open it in Figma, copy it to your drafts, and when you're ready, let's get started on this section, which I'm the most excited about in this whole course. Sometimes if I'm feeling overwhelmed by a project like the meme generator here, where we haven't learned some of the things we need to know in order to complete it, I will break the app down as much as I can into pieces and then see which of those pieces I actually can create. For example, we've spent this entire course so far learning how to build static React sites. And the truth is there are static parts of this site. So the first one we're going to start with is the header. Remember, you can click this screenshot in order to go to the Figma design, which you can use to determine the font sizes, the spacing, this cool purple gradient here, and so forth. So let's start out with that, pause the screencast, and work on building the header component. Well, first I'll get the pieces into place. I'm going to create a separate components folder, although this app is probably small enough that it's not really necessary. I'll just do it for practice sake. I'll create a header.js file inside of my components folder, and I'll just spin up a basic React component here. I'll do that little sanity check that I like to do just to see that it's working on the page. In my app.js, I will import my header. Let's put everything here in a div since I know that I'll have multiple things here. Okay, my header component is showing up. Next, let's get the content on the screen. I know it's not just an H1, so I think I'll surround this whole thing with a header element. And I probably wouldn't call this an H1 because it's not really the main headline of the page. It's sort of in the header itself. So let's maybe call it an H2. Before that, I'm going to have an image. And I already know the source is going to be my image's troll face. And let's see, it needs to be relative like this. That's probably going to be bigger than we want it to be, but we'll fix that in just a minute. And last of all, we have this React course project 3. I can't really decide what it should be. Let's just call it maybe an H4 or something. I know that I'm going to style my header, so I'll go ahead and give it a class name. We'll just say it's header. I'll hit save and go to my styles. Usually with two-dimensional layouts like this in a single line, I will revert to flexbox. So we'll say this is display flex. We'll align everything to the center. From the design, it looks like the height is maybe about 65 pixels. That's making my image overflow a bit. We'll fix the image in just a minute, but I'm going to grab my background, which is from the design, so I'm just going to paste it directly from the design there. The color of the fonts and the text should be white. And there probably should be a bit of padding. I think we have something like 15 on the top and bottom and 20 on the left and right, although it might just be 20 all around. We'll just call it 20 all around. Then I will give some class names to the other elements here. We have header image, header title, and header project. So we'll start with the image. And we'll make sure that this fits within the boundaries of its parent by saying you have a max height of 100%. In the design, it looks like there's also some space, about 6 pixels, so I'll give this margin right of 6 pixels. The header title It has a font size of about 20 pixels. And I can push my React Course Project 3 all the way to the right by giving my title a margin right of auto. We can see that a little more readily if I make this wider. Oh, and this still says header component. Let's update that to say meme generator. And let's lastly style our project text. That has a fairly small font size. We'll say that's about 12 pixels. And I think the weight is maybe different. Let's give it a font weight 500. And yeah, that does change it. So we'll leave that on there. And you know what? One thing I'm trying to get better at is using rems for my font size instead. 20 pixels over 16 pixels equates to about 1.25 rem. And 12 pixels over 16 is about 0.75 rem. Well, it's exactly 0.75 rem. Awesome work. This is a great start. The next thing we can do is attack this form here. We've got 2 inputs and a button. We're not quite ready to make them functional, but we can at least get them on the page. So let's do that in the next challenge. The next piece of our project that we can bite off is the form that we have right here with the 2 inputs and the button. So that's your challenge for this screencast. Don't worry at all about creating any functionality for it. I've outlined exactly the steps that I want you to do here. We're going to create a component called meme. Inside that meme component, we'll render a styled form, which will have our 2 inputs and our button. Pause the screencast and work on this challenge. Let's actually work backwards this time. I'm going to pretend that I already have a meme component created, so I'll just import it and render it since I'm already here in this file, and then I'll actually create it. So inside of components, I'll create meme.js and set up my component. Now, I didn't talk about this specifically, but I happen to know ahead of time that I'm going to put both my form and the actual meme image and this text all into this same component. The reason I want to do that has to do with when we start talking about state and where state needs to live. So in an effort to reduce complexity, I'm just going to put everything in the one component. The reason I mention that is because I already know ahead of time that I'm going to use a main element to surround everything else on my app. If you didn't do that, it's completely okay, but this inside of here is where I'm going to put my form. I already know that my form has 2 inputs and a button. I've already got my button text copied and I'll paste it here since it's got the little emoji there. I also know that I want these to be a type of text, so I'll add the type text there. Let's hit save, see what we're working with. Okay, pretty generic styling. Let's give this some love in the CSS. I think the way that I would like to lay this out is using grid. I could probably use Flexbox as well, but what I'll do is make a 2-column and 2-row grid and lay the elements out there inside. The grid will be the form, so I'll make that the grid container. I'll give this a class name of form. And while I'm here, I think I'll give these their own class names as well. I'm going to put these on their own lines. We'll say these are form inputs, and I'll give my button a class name of form button. I guess I can also give my inputs some placeholder text, so we'll add top text and bottom text. It's a little more helpful. Now in our CSS, let's select our form. We'll change it to display grid, and then set up a grid template that has 2 40-pixel rows, and then evenly divide the columns with fraction units. So we'll have 2 columns, 1 FR each. Since I have 3 items, it's putting the first item filling up 1 column, the next item filling up the next column, and then the third item only filling up 1 column. The inputs look essentially the way that I want them to, but I want the button to span the whole thing. So I'll select my form button and tell it that its grid column will go from the very beginning to the very end. Awesome. It looks like in the design there's a little bit of a gap. I can use the gap property to spread things out a little bit. Then of course, everything is butting up against the edges of my page here. I only am going to have one main element, so I'm just going to select the main element directly. And let's give it a padding, I think of about 36 pixels is what the design shows. One thing you might notice is that the placeholder text and the button text are not taking on our Carla font family. For whatever reason, inputs and buttons inside of forms tend not to do that. So I will specifically add that in my form button, and I will also select my form inputs. And I think I'll put this above my form button since my inputs are above my button in the markup. And I'll give that the font family as well. Let's also get some border radiuses here. I've got both of these as having a border radius of 5 pixels. My inputs have a border of 1 pixel solid, and then this color that I'm copying from the design. And oh, we need our hash mark there. There's a fun property called text indent that I learned about here. I can make it so that my placeholder text and my actual input text will bump in a little bit or have a little bit of an indent. We'll just give it a 5 pixel indent. And I just noticed that these styles are not applying. That's because I need this to say form input, not form inputs. Okay, that's working now. Let me comment this out. Yeah, you can see what the text indent is doing. Okay, my button needs a lot of help. I'm going to take the background from the design in the Figma file that also gives us that gradient of purple. I need to change the color to white. I'm going to remove the border. I always like my buttons to have a cursor of pointer. And awesome, that's looking great. It looks very much like our design. Now, at this point, I probably could separately create this image with the text sitting on top, but I think it's high time that we jump into actually understanding what it is we need to learn in order to do the functional parts of this application, including clicking the button and typing in our text. So in the next cast, we'll talk about what that will actually take. The primary thing that sets apart a static website like we've been building so far with web applications is the ability for the user to actually interact with our page. And in order for a user to interact with our page, we have to be listening for different events on that page and then reacting when those events happen. Let's get a quick overview as to how this app will work. As soon as the app loads for the very first time, it's immediately going to make a call to an API called ImageFlip, which will return to us an array of 100 meme images that are the most popular at that time. Then, clicking the Get a New Meme Image button will simply randomly choose one of those 100 images in the array that got returned to us. And as you've probably figured out, typing into the left input box will give us our top text, and typing into the right input box will give us our bottom text. Now, there's a lot in there that we need to break down before it becomes overwhelming. So let's start off really easy. The first thing we'll do is learn how to add an event listener to our button so that we can run some kind of logic when the button is clicked. And we'll start that in the next lesson. The primary thing that separates a static website from a web application is the ability for the user to interact with what they see on the screen. By now, you should have built plenty of JavaScript applications that used events and event listeners to allow the user to interact with your application. So this topic shouldn't really be new to you. You should already be familiar probably with 2 different ways that in a vanilla JavaScript application you can add events to your program. First of all, there's the .add event listener, which you probably are already familiar with. If you were adding a click event, you would then provide a function, and inside this function, you put the code of whatever should happen when the element that you're listening for an event on gets clicked. Alternatively, there's a way in HTML where you would essentially put on click and set that equal to the name of a function followed by parentheses. This second way is going to be much more similar to how we actually accomplish adding event listeners to items in React. For example, let's start with our button here. We're going to make it so that when we click the button, something will log to the console. In React, all I need to do is on my button, add an onClick. And you'll notice that I used a capital C. And that's because we are accessing the DOM properties of the object that's being created here. As a reminder, what React is doing is it's taking this JSX element that it sees, which in the end returns a plain JavaScript object describing the DOM element that should be created by React. And whatever properties or attributes we add here inside the JSX are directly accessing the equivalent properties in JavaScript. If I were to select this button in JavaScript using document.getElementById or something like that, I would have a DOM element that has a property called onClick with a capital C. And this camel casing is the standard throughout all of our JavaScript elements. So all that means is that instead of using the lowercase c like you might be used to doing in HTML, we're going to have camel cased properties everywhere. So on click, maybe on mouse over, or on mouse enter, and so forth. Let me put this back to on click and we'll see the other difference here. Now, instead of setting this equal to a string, which has a function name, because I'm here in JavaScript, I can actually just use a set of curly braces and then put a function directly here inside of my onClick. Now, personally, I'm not a big fan of stuffing my functions inside of my markup here if I can avoid it. So what I usually do is above my return, but still inside my component, I'll define another function up here and say handle click maybe, because this is the click event handler. Then I can say console log I was clicked. Let me get rid of this and I'm going to give you a mini challenge. Okay, pause the screencast and make it so that clicking the button will run our handle click function. A few of you may have been tricked into thinking that you can put handle click with a set of parentheses. And well, let me refresh and see what happens. Notice that as soon as I ran this code, it ran my handle click function. I don't want this set of parentheses here because that will run this function as soon as the program reads this line of code. Instead, I'm passing the function as a value so that React can add that function as the event handler in case a click ever happens on this button. So without the parentheses there, I can hit refresh, I'll clean this up, I can hit click me, and then that's when our click event handler runs. The React documentation has a full list of all of the events that it supports. I've included here a screenshot that you can click from the React documentation. This will take you specifically to the mouse events. I've personally found that mouse events probably make up a good 95% of the events that I listen for in any program I write. And you'll probably need to use this as a guide for the challenge that we will do right now. Your challenge is to log something to the console whenever the mouse hovers over the image. I added some CSS to darken the image just so it was a little more obvious when the mouse was actually hovering over the image. Again, feel free to use this as your reference. Pause the screencast and work on this challenge. There's a couple different events that should work just fine for this challenge. We have onMouse enter, which will run anytime the mouse enters an item that we're listening for an event on. And there's also onMouse over, which essentially does the same thing. It just has a slight difference dealing with children elements. Right now, we don't have any children elements of our image, so it really wouldn't matter which one we use. First, let me create a function that will run when we are hovering over the image. Maybe I'll say handle onMouse over. And we'll console log mouse over. And then I can simply add to my image, let's put it after the source, we'll say on mouse over equals, and then curly braces because I'm going to put the name of our handle mouse over function. Pull these onto separate lines to make sure that we can see them well. Hit save. And now when I hover over the image, or rather when there's a mouse over event on the image, it runs our JavaScript code and we get that console log displaying down there. Feel free to poke around the documentation. Event listeners can be kind of fun, especially when there's a bunch that you may not have heard of. Just seeing how they work can be a fun thing to play with. Understanding this is going to be assumed from here on because you already should be a little bit familiar with events and event listeners at this point. Fortunately, doing it in React is actually fairly straightforward. And now this sets us up for one of the coolest parts of React, and we're going to jump into that next. Let's apply what we just learned about event listeners to our meme generator project. Ultimately, what we'll be doing is making an API call as soon as our component loads and getting data from an API that includes 100 of the most popular meme images right now, but we haven't quite yet learned everything we need in order to make that work. So for now, what I've done is I made the API requests and I just saved the data that came back here in memesdata.js. You can see we have the object, it's got a data property that has a memes property, and that is an array of 100 items. Each one of those items is an object that has a URL property. So you're going to have to do a little bit of digging into this memes data object, but your challenge is to make it so that when we click the button, it will randomly choose one of those URLs and just log it to the console. For now, don't worry about displaying the image yet. One modification I made to our markup here is I changed our form element into a div element. Long story short, when you have a button inside of a form, it actually submits that form and tends to refresh the page unless you stop it. But I realized that there's actually no reason for this to be collected together in a form because ultimately this button does its own thing by getting a new image. It does not take these inputs and submit them somewhere. So in this case, I feel like it's okay to have our inputs floating outside of a form, and that way it means that when we click our button, it doesn't refresh our page because it's not trying to submit a form. Okay, so the challenge is to get a random image from the memes data array, which I've already imported for you. You'll get that anytime this new meme image button is clicked. For now, just log the URL of that new image to the console. If you're feeling hazy on how to get a random item from an array, you'll probably want to turn to Google, but I know that you'll be able to do it. Pause the screencast, work on this challenge. Let's start by hooking up our button. I'm going to add an on-click event listener, and when the button is clicked, I will run a function that says get meme image. I haven't yet created that, so let's create that function, get meme image. For now, I'll just have it console log clicked to make sure that everything is hooked up correctly. I'll hit save, click the button, clicked. Okay, good. Now if we look closely at memes data, it's an object. There's the object. It has a data property, which has a memes property. So I need memes data.data.memes, and that's my array. I think I'll simplify that by simply saying const memes array equals memes data.data.memes. And then I will generate a random number. So I'll say random number, and I can use math.floor, math.random times the length of my array. So that's memes array.length. This random number should get me a random index of my memes array, and that indexed item will be an object with a URL property. So let's actually just console log random number and see how we're doing so far. 16, 50, 92. Okay, I wanted to see a high number to make sure that it was going up to 100. I probably don't need to click this until I see 100, or actually I think it would be 99. So I can get my image object, or actually I can just do it all in one. I'll say const URL equals, and then I'll index into memes array at the index of random number. This is my object with a URL property. So I'll just save that as URL so it's nice and short. Or if we wanted to do some object destructuring, I could just say, get me the URL property from this memes array. I don't want to conflate a few things here, so I'll just keep it straightforward like this. And then we'll just console log the URL. Of course, I could do probably most of this in a single line, but I find that sometimes separating it out makes it a lot easier for other people to read. We'll hit save, and I guess I have no way to ensure that these are in the correct index, but I can't see why they wouldn't be. So this is awesome. We're getting random images every time we click our button. At this point, we are a little bit blocked, and I'll show you why. If I create, let's say, a paragraph down here, and I try to stick my URL in there, well, first of all, I have a problem because my URL is only declared inside of this function. And so this is not going to know what I'm talking about. If I hit refresh, it's going to say it doesn't know what URL is, essentially. So you might think, well, let's declare URL outside of the function. You could say let URL, and then just set URL equal to this and console log URL. Let me hit save, and now at least URL is, well, of course, my styling is all messed up because my paragraph is, let's put this outside here so we have that above. Click new meme image. Okay, well, we set URL equal to the new meme image right here. However, my UI did not update. This has everything to do with the way that React looks at variables and decides when it should update the UI or the user interface. And spoiler alert, it doesn't do that by just looking at every variable that we declare inside of our component. In the next cast, we're going to dive a little deeper into this conundrum that we have and start figuring out how we can make it so that we can update a variable that will then replace what we have on the screen with the new value of that variable. At this point in our journey, we have mostly been dealing with static websites. In the previous section, we showed how we can take data that we pull from, for example, an API. We were just using a little JavaScript local data file to mimic pulling from an API, and then we mapped over that array of data to display items on the screen. However, in order to interact with those items on the screen, we are still missing something. I want to demonstrate what I mean, but before we do that, just in case it's been a little while, let's get our hands in the keyboard with a quick challenge. I have here just a locally defined array with two strings in it, thing1 and thing2. I want you to map over the things array, generate a paragraph element for every item in the array, and then render those items below the button right here. This challenge harkens back to the last section where we learned about .map and how to take an array of data and turn it into elements on the page. So pause the screencast and work on this challenge. Okay, what I'll do is create a new variable called maybe things elements. And I will set that equal to the array that comes back when I run .map on my original things array. We'll look at each thing in this array, which is just a string, and we'll return a JSX wrapped version of that string, so really just a paragraph element in JSX, where what we insert on the inside is the text of that thing. Thing is just a string, so it's fine if I just put it inside of my paragraph like that. Then things elements is an array of paragraph elements, and I can just put that inside my curly braces here, hit refresh, and now I have thing1 and thing2. I did get that warning about key, so I should probably just add a key prop here, and every one of these strings will be unique. We'll see why in just a second. So I'm just going to say that thing is the key, and that should set them apart and get rid of my warning there. Cool. Well, this is great, but we've got this button that doesn't currently do anything. Let me set up another quick challenge for you. The concept is going to be that you click the Add Item button, and it adds another thing to our things array, namely thing 3, and then you click it again, it'll be thing 4, and so forth. I'll type up this challenge now. Okay, your challenge is to add an event listener to our button so that when it gets clicked, it adds another thing to our things array. In your event listener, you can use thingsArray.length plus 1 to determine what number should get added to the next item in this array. And it also will be a good idea to make sure that at the very end of that event listener that runs when you click the button, that you console log your things array. And the reason is because, spoiler, the page is not going to update when you add new things to the array. I decided it would be important to let you know this little fact ahead of time so that you weren't pulling your hair out trying to figure out why the heck things weren't changing on the page. So pause the screencast and work on this challenge. Well, let's create a function called, we could call it handle click, or I could say add item maybe. And add item is going to, well, first let's just console log things array and set up our onClick add item so that we can see that it's working. Okay, so it's logging thing1 and thing2, the static array that we have there. So I probably could add the whole thing in one step just using things array.push. I'm going to determine what the text of the new thing is first. So let's say new thing text, and that's going to be, I'm going to use a template literal so I can say thing space and then insert some JavaScript where I say things array.length plus 1. And then I can say things array.push new thing text. And then of course I'm going to log the things array after I push the new item. Let me open the console so we can see that a little more clearly. I'll hit save. Add item. Okay. Oh, not a number, of course, because I spelled length wrong. Let's try that again. Add item, thing 3, thing 4, thing 5. Great. Well, our array is changing, but of course what we see on the screen is not. And this brings us to our conundrum. At this point, React is not looking at local arrays that are just saved within a component to determine whether or not something should get re-rendered, or rather if the return here should run again with an updated value for things elements. Actually, maybe more specifically, I'm determining my things elements way up here at the top, back when things array is just 2 items long, and then it's sort of cementing this things elements into its memory, and no matter what I do to change things array, it's not going to automatically change things elements. In my early days, I thought maybe if I put this below add item or something like that, it might make a difference, but that's not going to change the fact that this line of code will only run one time, and that's the very first time the app component gets rendered right here. Let me clean this up real quick. Now, one thing that might be tempting to do is inside of our add item function to say, well, let's not just update our array, let's actually select the elements on the screen using document.getElementById by ID and finding out where the container for these items is, and then pushing a new paragraph element to that list. And the truth is, when you're just using plain JavaScript, that's essentially what you have to do. But if you think back to one of our earlier sections, we talked about how React is declarative. And this is one of the major benefits of having a declarative library like React. It makes it so that all we really need to do is update our data, and React will automatically, react to that change and update our UI to display what has changed in the data. All we need to be in charge of is making sure that the data updates correctly, and React will handle the rest. However, for that to work, we need to access something called React State. And state will allow us to sort of hook into the component and make it so that whenever we update our state, which is really just values that we're saving inside of this component, it makes it so React will update the user interface based on any changes that happen to those values that are being saved in state. And truthfully, if you think of pretty much any website that you interact with, if it were made in React, any kind of interaction you had would change the state. The first thing that comes to mind is maybe, a playlist or a recipe where you hit the little heart icon or maybe a bookmark icon, and it fills it in and likely sends a message out to a database that updates the fact that you have liked a recipe or a song. Or maybe it's an accordion or a carousel where you click something and an image shifts over or a portion of the page expands so you can read more information. Any of those interactions in React are going to be updating state, which then makes it so that React can update the user interface to respond to however you interacted with the page. So now let me update this using state, and you can see how it will actually start to work again the way we originally expected. Obviously, at this point, some of this will look a little bit foreign, and that's totally okay. We're going to dive deep into understanding how to actually write this ourselves, but you can see that not that much changed in my actual code, but suddenly I have an app that's working the way that I expected. The example is a little bit contrived, obviously, but hopefully you can see the exciting world of state in React that we're approaching and start to imagine some of the cool things that it's going to allow us to do. So buckle up and get ready to jump into React State. One thing I've learned over my years of teaching React is that one of the major points of confusion for students when they're first learning React is understanding the difference between props, which you have already learned, and state, which we are about to learn. So let's take some time and clarify the differences between the two and when you would want to use one over the other. And the first thing we'll do is look at props. We've seen how we can implement props in practice, but let's take a second to actually talk about them. When we refer to props, we are referring to the properties that we are passing into a component in order for that component to work correctly. This is similar to how a function can receive parameters, quote unquote, from above. Just like a function that receives parameters, a component that receives props is not allowed to modify those props, or in other words, those props are called immutable. Let's first take a look at a regular function. Let's say I define a function that says add two numbers, and I pass in my parameters of a and b. As I'm writing the logic of this function, I'm going to assume that this function will be passed a and b. Of course, I could always do some kind of check that says if there's no such thing as a, or if a is equal to undefined, then throw some kind of error that says you need to provide both a and b. But other than that, inside of the body of the function, I can just assume that I have a variable a, which is a parameter that has been passed to this function, and I can assume that I have a parameter b, another parameter passed to this function. And that's what I mean by being passed from above. When we actually use this function, we'll say add two numbers. I'll provide my actual values that I want to represent the parameters a and b, and my function can then do its job. The main point that I want to come across here, however, is that inside the body of this function, it wouldn't make a whole lot of sense for me to modify or mutate these parameters. For example, I wouldn't want to say, forget what you just gave me for a, I'm going to set it equal to 42. Naturally, this should feel wrong to you because essentially we're ignoring anything that is passed in as the first parameter here and just setting it equal to 42. Technically, this probably works. If I were to console log the result from add two numbers, 1 and 2, of course I would expect it to be 3, but we'll see that it's actually 44, and that's because we've overwritten a to be something different. Similarly, in React, I would never want to have a component, let's say a navbar, that takes props, but then automatically sets props dot, I don't know, let's say cover image equal to something else. This is a huge red flag. You would never want to set props.anything or props itself equal to anything different, because incoming props should be immutable and they should never change manually. Or maybe more specifically, those props should never change from within the body of our component itself. Now, that's not to say that when I have an instance of my navbar that I can't provide a cover image that changes. Let's say it starts out as some image 1, and then, I don't know, maybe there's a button on the screen. When the user clicks that button, I want my navbar's cover image to update to some other image. Maybe this is a little convoluted because I'm not really using images here. But the point is, I can change the values that I pass to my component. That's fine. That's something I'm allowed to do, and as we jump into state, we're going to see why that's even useful. But from within the body of the function, I should never ever change my props, in the same way that I would never want to change the parameters being passed to my function. Another way to think about props, here we read that they are the properties being passed into a component in order for it to work correctly. If it helps, you could think of it as the properties being passed to a component in order to configure it. As we saw in our last section project, we passed props to our card component in order for that card to be reusable and configure it to display the correct image, the correct price, the correct stats like the review count and so forth. And oftentimes you'll find components that do more than just take in the data that should just be displayed as a part of the component. Sometimes they will receive configuration objects or properties. Let's say, for example, off the top of my head, if we had a component that we wanted to display either in light mode or dark mode, well, then maybe I would have a dark mode property that I could set to true. In this case, I'm not necessarily displaying the literal text true for dark mode or the text dark mode is activated or anything like that, but instead this is a property that is configuring my navbar in order for it to act and display correctly. Okay, I might be beating a dead horse here, so let's move on, and we're going to see how the use of state will differ from our usage of props. If props are data that a component is receiving from above and shouldn't be changing, state, on the other hand, are values that are defined within a component and essentially should be changing. So as we see here, state refers to any values that are managed by the component itself, kind of like a function that declares its own variables from within that function. Long story short, anytime your component has changing values that should be saved and displayed, you're most likely going to be using state. We'll jump into what this looks like in React in a second, but I think it might be helpful to see how this compares in a vanilla JavaScript example, kind of like we did with our add two numbers and having what we can equate to props being passed in as these parameters, and how we shouldn't be changing them from within the definition of this function itself. In order to create an equivalent in vanilla JavaScript of our concept of state, let me write out a challenge for you. Let's say we have a function called greeting. It takes a name as a parameter, and what it should return is a string like good afternoon and then followed by the name. Of course, afternoon will change depending on the current time of day, as you can read from the challenge description up there. At this point, this is more of a vanilla JavaScript algorithm challenge for you, but I think it's good to incorporate those into our React course here. And maybe just so that I'm not making you chase Google a whole bunch right now, I'm going to give you a couple hints here. So you can get the current time of day by following these two lines of code. Essentially, first you create a new date object in JavaScript, and then you use that date to get the current number of hours. These hours are 0 index, so 12 a.m. is 0, 11 p.m. is 23. And just to be clear, I have included the 11:59, 4:59, and everything up here just to be clear what hours should be included in morning. This one's kind of funny because I don't know that I would ever say goodnight to someone at 3:59 a.m., but whatever. My point is you won't need to get the minutes here. You can just use the hours like I've shown you here. Pause the screencast, see if you can complete this challenge, and then we're going to bring the concepts back into understanding state in React. Now, I won't spend a bunch of time talking about the logic of this. We'll just put in a solution here and then talk about how this equates to state in React. I have the number of hours now. If I console log those hours, it's 12 p.m. my time, so my answer should say 12 there. Yep. So I will type out some logic that I think will just kind of intuitively make sense. The first thing I'll do is just declare a changeable value here, time of day, and then depending on the current number of hours, I will change the string time of day to be either morning, afternoon, evening, or night, just like I talked about in the challenge. And now that I have a time of day value, I can simply return the string, and I'll use some interpolation here. We'll say good, and then we'll stick in the time of day, comma, and then I'll use the value for name that I'm receiving as the parameter to greeting, exclamation point, and let's go ahead and see if this works. Again, it's about 12 o'clock my time, so I should, when I'll need to console log this, the value that gets returned. Good afternoon, Bob. Okay. Now, the point here is my function is receiving a parameter. This parameter is not something that I will want to change in the way of saying name equals something different, because that would just be a kind of a strange thing to do when you are expecting the outside user of this function to provide you the name. Similarly, in React, we are not going to take any props and then just change them, which is what we talked about in the last screencast. However, there are definitely reasons for us to, within our own function, create values that we can either use or even change, like our let time of day here. In React, values that are created by the function or the component itself are usually handled with state. Okay, I think that's more than enough of the conceptual difference between props and state. At this point, it's probably best for us to just get our hands dirty and start actually seeing how we can implement state in React. And then as we build our section project, we will get much better exposure into how state and props will work together and how they are different from each other as well. It's time for another quiz. This one's going to specifically be looking at the difference between props and state. So, as always, read through these questions, click into the editor, type down your answers, and when you're satisfied with your answers, click play and we'll go through the quiz together. On a higher level, the concept of state is sort of like saying the way things currently are. Here in the United States, the president gives a yearly address called the State of the Union. Growing up, that always confused me because the United States is made up of 50 states, and I thought it had something to do with that. But no, it means the way that things currently are. In React, state refers to values that a component can maintain between render cycles. This will make more sense when we get into the syntax of it, but let me type down a more concise answer to this question. The concept of state is essentially a way for React to remember some saved values from inside of a component. This is similar to declaring variables within a component, but there are a few added bonuses to it, which we're going to get to later. So when would you use props instead of state in React? I think the easiest way to think about this is to compare it to regular JavaScript functions. Props are like passing parameters into a function that the function then uses to help it determine the output, what gets returned. So in React, you would want to use props anytime you need to pass data into a component so that that component can use that data to determine what should get displayed on the screen. In some cases, the data that we pass in will directly be data that is displayed, like in the instance of text. But sometimes it will be data that's really just meant to, so to speak, configure the component so that the component can use it to determine how something gets displayed. Okay, so when would you want to use state instead of props? Continuing with our function analogy, state is kind of like when inside of the body of a function you declare new variables, and you use those new variables to help you accomplish some task inside of the function. In React, you would use state anytime you needed a component to maintain its own values. As we mentioned earlier, it's slightly different than just declaring a regular variable. We're going to see the syntax of it later and how it differs, but for now that should be a sufficient answer to this question. So you would use state anytime you want a component to maintain some values from within that component, and by the way, also remember those values even when React needs to re-render the component. Again, we're going to see that much more in detail a little bit later. And a little bit out of left field, what does the term immutable mean? And then are props immutable and is state immutable? Immutable technically means unchanging. The reason I bring this up is because we learned that props are immutable. We should not ever change props from within the component that's receiving props. Doing so essentially defeats the entire purpose of props. Think of it like a function that receives a parameter but then just decides to change the value of those parameters to something different. It pretty much invalidates the whole purpose of passing parameters into a function. So props are immutable. In this case, I don't think props are literally immutable. You can try to set them equal to something else, and I don't believe it will crash your program, although it may throw a warning. But maybe a better way to describe it is saying that you should not change props, and therefore they are immutable. State, on the other hand, is not immutable, or in other words, state is mutable. The purpose of declaring state in a component is because you do plan on changing state. Okay, we're done with the quiz. Nice work. When you're ready, let's keep moving forward. We saw in an earlier lesson how it's not going to work for us, at least in React, to just declare regular variables like, let's say, state is equal to yes, and expect React to re-render our component if for some reason that state ever changed. If you recall, we had an array of items, and we had a button that allowed us to push new elements to that array. But whenever we did that, it didn't actually update our page. And that's because React doesn't watch for local variable changes. So the first thing we'll do is learn how to actually declare state inside of our component. And in the next cast, we'll talk more about how to actually change that state. As a part of the React library, there is a method called useState. And useState is one of many what are called hooks in React. There's a little bit of history as to why it's called hooks. We're probably just not going to worry too much about it right now. But the point is I can declare some state by simply calling react.useState. Now, another way you might oftentimes see this is people will destructure it directly in the import statement. They'll grab the useState method from React as well, and then they can just use useState. In fact, I would suppose this is the more common way you will usually see it happen. However, just for perfect clarity and for it to be very clear that useState is part of the React library, I'm actually going to use react.useState because I do find that it makes it a lot more clear where this useState method is coming from. Let's go ahead and see what comes back. We'll say const result equals react.useState, and then we'll console log result, just to see what actually comes back by calling react.useState. I'll open the console, hit save. And look at that. Okay, so that's interesting. We get an array back, and the array has its first value as undefined, and its second value, well, in Scrimba it says f parentheses. That just means that it's a function. Now, let's see what happens when I put something inside the parentheses. Let's say the string hello. I'll hit save, and now the first value of my array is the string hello. So whatever I put inside of my parentheses when I'm calling useState is going to be the default value for the state variable that I want to save. Okay, so now that leads me to a little mini challenge that will require you to think a little bit critically. I'm going to type the challenge out now. Okay, your job is to replace this yes with a string yes that isn't just hard-coded inside, but rather is created by using react.useState. Remember, what we get back by calling react.useState is not just the string hello, it's actually an array. So let that guide you as you work this challenge. Pause the screencast and work on this now. The first thing I can do is change hello to yes, and then my result is an array, and the index of 0 should be, let me just log this, should be my string yes. So I could replace this yes with a set of curly braces because I need to jump into JavaScript, and then I can say result at the index of 0. I'll hit save, and we get yes the exact same way we had it before. But now if I were to change this to no, which is not true, state is important to know, awesome, our page actually updates with the state that we had created with react.useState. Change this back to yes, because it certainly is important to know. Okay, well there's a couple of problems we have. First of all, this is kind of clunky to say result at the index of 0. In the next screencast, we're going to learn a little bit more about what we can do with this array, and then we will bring out the real power of using state by allowing the user to interact with our page and change state themselves. So when you're ready, let's jump into those topics. As we saw, what we get back by calling react.useState is an array where the first item is the value of the state that we are hoping to save, kind of like initializing a variable inside of our component. And the second item of that array is a function. So we saw how we could use result at the index of 0 to get our value. However, there's actually a much smoother way to deal with this. And this requires us to use array destructuring. Since react.useState returns an array, what we can do is actually destructure that array immediately upon receiving it as a variable, and then we can provide two values, and let me just put func because we know the second value is a function. Now in this case, if I rerun console log result, what we see is that we have pulled out the first item in the resulting array of react.useState and destructured it into its own variable called result. What's nice about using array destructuring is that we get to call this whatever we want. If this were object destructuring, we would have to use the property name of the object that comes back by calling react.useState. But because they return an array, we can call it whatever we want. So if I console log whatever we want, we get the same thing, yes. Oh, and now my result down here is broken, so if I change that to whatever we want, we get back to the way we were. Now, don't use silly names like whatever we want. Instead, let's say maybe is important. We'll choose a variable name that makes a lot of sense for what the value is that we're trying to keep track of. And that's the concept of using array destructuring in order to more smoothly get values from react.useState. In the next screencast, let's talk more about this function here. Let's take a look now at the function that we receive here when we destructure the array that comes back from react.useState. Normally, if we had a variable where we were saving this, if we just said something like let is important equal yes, then we already know we could simply say is important equals something different, like no. However, when we're working with state, we can't simply say is important equals something different. Instead, we are given a function that allows us to make these changes so that React can handle those changes accordingly. Let me delete these lines here, and let's take a look at this function. Now, normally we wouldn't just call this func, so let's give this a more meaningful name. The convention that you'll oftentimes see is set, and then the rest of the variable that we called our state. So set is important. In this case, I need a capital I to make my camel casing correct. And this set is important is a function that I can run, and whatever value I provide to it is going to be the new version of state. Now, of course, running this function immediately after generating state is kind of silly. In fact, I'm not even certain that it would work. Instead, we would normally want to set or change the state whenever something specific happens on the page. So let me type up a challenge so we can do something like that. Okay, just to avoid confusion, I created the actual function body for you, but your challenge is to have this function run this line of code, and then to set up an event listener on this div so that it runs handle click whenever anywhere inside this circle gets clicked. Pause the screencast and work on this challenge. Well, simply enough, I can copy this line of code, put it in there, and then I need to set up an event listener here. So I'll say on click, again, capital C. We will run our handle click function. Hit refresh. And when I click my button here, awesome. Okay, notice that as soon as I clicked, it changed from yes to no. What happened is we took the function that we were given when we called react.useState. This function's job is to give us the ability to change state if we wanted to. And we used it in the most simple way possible, which is to simply provide a new version of state. As soon as this line gets called, which of course happens as soon as we click our div here, then setIsImportant gets called, and the state changes to no. And well, at this point, we've kind of hit a dead end, because obviously this is incorrect. State is very important to know, but notice that if I click this again and again, well, nothing is changing, and that's because every time I click it, it immediately sets it to no. In the next screencast, let's work on a challenge that will help get your hands on the keyboard practicing using state. All right, here we have something that's a little more dynamic. The idea is we will create a little counter. When I hit plus, this number should go up. When I hit minus, this number should go down. To start us off and to get your hands on the keyboard, I'm going to have you complete this challenge where you're going to set up state to track our current count. And our initial value is going to be 0. Pause the screencast and see if you can complete this challenge. To create new state, we simply use react.useState. And we can provide the initial value of 0, and then we need to essentially catch what this returns in some variables. It's an array, and because what we get is an array and I can destructure it, that means I can call it whatever I want. In the first index, I receive the value, which I'll call the count, and by convention, I will call my setter function setCount. This is the function that when I call it will allow me to update the state here. One last thing that I didn't specifically say to do and wouldn't be very obvious unless I did is to use this count value to replace our 0 here. Now at this point nothing is going to look like it has changed. I still don't have the ability to raise or lower this number. Now let me build up to the next section by updating our challenge. Okay, your challenge is to create a function that's called add that runs whenever the plus button is clicked. This is just practice on event listeners in general. For now, you can just have it console log the string add or something along those lines. A good rule of thumb to use is to declare these functions inside of your component. So instead of going up here outside of your component and creating your function called add, it's better to declare that function right here inside of your component. Pause the screencast and work on this part of the challenge. Okay, let's declare a new function called add. And for now, we'll just console log add. And let's see, here is my plus button. So I will add an on click of add. And now I should click this button and get my console logging add. Awesome. Okay, at this point, we're running into an issue, and that is how we can update our count. What we most recently saw is that I could say set count and then provide some kind of immediate hard-coded value here. However, that doesn't really help us because even if I provide a 1, if I run this code, it will work. Notice that when I click the add button, it sets the count to 1. Therefore, it re-renders our app and changes the 0 to 1. However, of course, if I hit plus again and again and again, it's just constantly setting it to 1, and it doesn't really accomplish what we want. So I want you to think critically. I'm going to update our challenge. I want you to see if you can think of a way so that clicking the plus button will increase our number by 1 every time and display it correctly on the screen. Obviously, hard coding a 1 here is not going to work. Pause the screencast and see if you can figure out this challenge. Hopefully you were able to figure out that we do have access to our current count. And so I can just say I want you to set the count equal to whatever the current count is plus 1. Let me hit save. We'll see that this is working. Okay, that's awesome. But I wanted to use this as a chance to show you a common misconception or fallacy that beginners in React tend to fall into. And that is trying to do something like count plus plus, or even plus plus count if you're familiar with the differences between those two. Let's look at count plus plus, for example. In the philosophy of React, something like count plus plus is strictly forbidden. And that's because we never want to modify state directly. What I mean by that is this. Count plus plus is a shorthand for count equals count plus 1. And in this case, using count equals is just a big no-no. You will never ever do that when you're modifying state. The entire reason that we have this set count function is so that we can simply provide a new updated value, but we will never ever want to run an equal sign after our state value. So let me put this back to count plus 1. We'll see that this is working. And now I want to update our challenge to finish off the basic portion of this app. Okay, your task is to add functionality to the minus button now. Of course, clicking the minus button should decrease our number by 1. Pause the lesson and see if you can figure this one out. All we need to do is to create a subtract function instead. So I'll create a new function called subtract. Of course, this one should take count and subtract 1. And then we need to add our onClick handler for the minus button. So that will go right here. Subtract. And once I hit save, we should be able to go backwards as well. Awesome, great work. However, I do have a little bit of bad news. Although we were able to use our count state value here in order to help us determine the new count, it turns out we're not actually following best practices when it comes to using this state value here. So in the next screencast, we're going to see another way that we can use the setCountSetter function to update our state value. Although currently it's technically working for us to use our current state value in order to determine the new state value when we're setting our count, it turns out there's actually a better way to use setCount in this case whenever we need to use our old version of state to determine our new version of state. We've seen how we can simply provide a new value to our setter function. However, there's another way that we can use this setter function, and that is to provide a callback function inside. When we provide a callback function as the parameter to our setter function, this function needs to return the new value that we want state to be. If we essentially wanted to recreate what we did by passing a simple value to our setCount function, we could just have our callback function here return count plus 1. However, this is where the best practices comes in. Anytime we need to use our old state value to determine a new state value, if we provide this function, React will pass this function the old value as the parameter here. What we can do is then take this old value and use that as our reference to what count was at the time that this function was called. This might be really confusing at this point. It would require us to jump a little bit deeper into how React handles state changes and re-renders to truly understand why this is best practice. For now, I think it's going to be enough to simply say if you ever need to use the old value of state in order to determine the new value of state, you should just always plan to pass a function to setCount. This might be a little disheartening because this already looks way more complicated than what we had here. Fortunately, if we use arrow functions, we can simplify this quite a bit. I can just say, given the old value, return old value plus 1. Usually what I'll do is use the prefix of prev and then use my state value. So I'll say prev count as in previous count. So this is the convention you'll usually see me using whenever I'm using a callback function as my parameter to setCount. Because that was a little bit confusing, I'm going to type this out as a note so that maybe those of you who are more visual learners will be able to comprehend it a little better. So again, if you ever need the old value of state to help you determine the new value of state, or in other words, if the new value of state depends on knowing what the old value of state was, you should always pass a callback function to your state setter function instead of using the state directly like we're doing down here. Then this callback function will receive a previous version or the old version of the state value, which you can then use to determine the new state value. With that said, let's do a quick challenge. Okay, your challenge is to update our subtract function to use this callback function as the state setter instead of what we currently have. Pause the screencast and update our subtract function. Fortunately, with arrow functions, this is still very concise. I can say prev count, arrow, prev count -1. And just for demonstration, when I refresh this, you can see everything is working exactly the way as it was. You're obviously more than welcome, if you're really curious, to deep dive into this, do a bunch of Google and YouTube searches to truly understand why this is better. Frankly, I would say probably 90% of the time you would never notice a difference between what we used to have and what we currently have. However, it is generally accepted as best practice to do it this way. And all of this is not to say that there's no instance in which you would want to just provide a bare value for your setter. That certainly does happen still. But in the spirit of teaching you best practices in React, it's probably good enough just to understand what I'm talking about here in this note and to move on. A good practice at this time might be to delete everything that we're doing dealing with state here and to try and recreate it from scratch. Maybe as a way to test your own skills to see if you are truly comprehending what we've done so far. When you feel like you've got a good grasp on this, let's keep moving forward. Let's pause now and do another quick quiz. Like you've done before, pause the screencast, click into the editor here, actually type down your answers to the questions that you see here, and then we will go through the quiz together. Pause now and work on the quiz. Okay, number one, you have two options for what you can pass into a state setter function like setCount. What are those options? Well, option A is to pass in simply the new value of state. So if you call setCount and you provide a new value like 42, whenever this function gets called, state will automatically be updated to the number 42. And option B is to pass a callback function. And then whatever the callback function returns, we'll say whatever the callback function returns will be the new value of state. And then numbers 2 and 3 both refer back to the answer to number 1. So when would you want to use the first option? In our case, the new value of state. This is any time you want to update your state and you do not care what the previous value of state was, or rather, you don't need the previous value of state to help you determine what the new value of state should be. And then the answer to number 3 is basically the opposite of number 2. It's whenever you do need the previous value of state to help you determine the new value of state. Under the hood, React is doing some relatively complex things to make sure that it can maintain state for you. One of those things has to do with batching a bunch of different state changes together. So if you were to run two state setter functions back to back, the way that React handles it may or may not run one of them before the other. That's a very high-level overview of why we need to do this, but when we pass a callback function to our state setter function, we can be guaranteed that the value that callback function receives, which in the previous lesson we were calling prev count, we can be guaranteed that it will receive the most updated correct version of that so that it can update state correctly. If that didn't make any sense, that's completely okay. That's really why I didn't want to dive too deep into it, because at this point it truly is enough to know that if you need the old value of state to help you determine the new value of state, you should pass a callback function. Otherwise, you don't need to pass a callback function. Okay, I'm probably beating a dead horse at this point. When you're ready, let's keep moving forward. Now that we've learned how to create and update our state, let's revisit our meme generator. We figured out earlier how to get a random URL for a meme image. However, the conundrum we ran into was that we couldn't update our user interface with that image because React wasn't listening to our local variables. Now that we know about state, we should be able to add an image to our meme generator. So your challenge is to first create a new piece of state called meme image that will just start with an empty string as a default. And when the get meme image function is called, you'll save the random URL, which we still have access to right here, in the state for meme image. Once you've done that, you should be able to add an image element below our div here with the form that has its source set to the new meme image state that you created. As a bonus, you may want to add some styling so that the image stays confined within the space that we're working with here. Pause the screencast and work on adding an image to our meme generator. Right near the top here, I'm going to create meme image and set meme image, which will come back from react.useState. The initial value is an empty string. Down in my get meme image function, we can call set meme image. And now think for a second, do I need access to the old state, the old string here, in order to determine what my new string should be? And the answer is no. I don't care what it used to be. I'm completely replacing it with the new URL, which I can get through memesArray at the index of random number.url. And that should complete these first two tasks. Lastly, I'm going to use my new meme image to create an image element and give it the proper source. Meme image, let's hit save. And well, it says we have an error. Let's go ahead and just see what happens. I'll click get a new image, and look at that. We've got an image now. Obviously, it's pretty large. Let's see if we can just add maybe a class name. And for now, let's call it maybe meme -- image. In my styles, I'll add meme image, and let's say it's got a max width of 100%. Hit refresh, click get a new meme image, and look at that. Now, I don't know immediately what this error is coming from. I think for now, I'm going to ignore it, and we'll see if we can figure it out later down the road. Awesome work. Now, this is just the beginning. We have a lot left to learn about state, but don't let that be daunting. It's going to be really fun. So when you're ready, let's keep pushing forward. At this point, it will be helpful for us to practice the ternary operator, whether you've learned it before or not. I've written some very basic JavaScript here. We just have a variable called isGoingOut that is set to the Boolean true, and then we are using that value to determine what the answer should be that we display in our H1 over on the page. Obviously, if isGoingOut is true, then we'll say yes, and otherwise we'll say no. If it's been a while since you've worked with the ternary or you never really fully grasped it, I've included a link here to the MDN docs on how to use the ternary operator. So once you feel prepared, pause the screencast and see if you can clean up our code using a ternary. A ternary allows us to put an if-else statement onto a single line. Technically, you can also manage if, else statements and get as nested as you want by using nested ternaries, but at that point, I really don't see a reason in using a ternary. It becomes much more difficult to read than a simple if-else statement. So here, what we're going to do is set our answer equal to, and then we'll use a ternary to determine if we are going out. So I could say is going out is true, and then I use a question mark that says if this is true, then I want you to use this expression. In other words, I want let answer equal to yes, the string yes. Otherwise, and this is my else, I'll say I want answer to equal no. I can get rid of all this down here, and I've been able to clean up my code from before to a single line. And if you're not terribly familiar with ternaries, the more you see this, the more natural it's going to seem. This is actually a really easy thing for me to read now because I've seen it so many times. So I can hit save, and everything is working here. We can see if I flip this to false and hit save, then we get the answer no. I can simplify this ternary even further because isGoingOut is already a Boolean. I don't necessarily need to equate it equal to true. So I can simply say if isGoingOut, in other words, if this is true or a truthy value, then set answer equal to yes, otherwise set it equal to no. And of course, we get the same values. Switch this to true, No will change to yes. Awesome. Okay, let me tweak this challenge just a little bit. There's one more way that you will oftentimes see a ternary used in React, and that is when the ternary actually exists inside of our markup. If you remember, our curly braces allow us to put JavaScript, not just variables, but entire expressions directly inside of our JSX. So your challenge is to move the ternary inside of the h1 in the JSX, and as a hint, you will no longer need the answer variable at all. Pause the screencast and see if you can figure out a solution to this challenge. All I need to do is take this part of my ternary here and replace answer with it, and then I can get rid of my answer completely. Now what will happen is every time my component renders, it will check the value of is going out, and it will determine whether the string yes should be used as the text of this h1 or if the string no should be used as the text of this h1. So just like we had before, I can hit save. We get yes because our value is true. And if we switch it to false, we get our answer of no. Awesome. This sets us up perfectly to work on the next challenge where we will actually save this value in state and then flip it back and forth between true and false. And that's what we'll work on next. Similar to last time, we have the question, do I feel like going out tonight? I've hard-coded this time the answer yes, but you will want to change that in the challenge. So your challenge is to initialize some state for a variable called isGoingOut, and you will just begin it as a Boolean. You can choose true or false as the default, and then make it so that clicking anywhere in this div will flip that Boolean value from true to false or false to true. And then instead of a hard-coded yes, you should display yes if isGoingOut is true, otherwise it should display no. This rolls together the topics of the past few screencasts, so if you need to look back and remind yourself how everything works, that's completely okay. Pause the screencast and work on this challenge. To initialize some state, I will simply use react.useState. As a reminder, you could also decide to pull in useState as a separate method from the React library by destructuring it up here. I'll set the initial value to true, and I will save it in a variable that I will use destructuring on because I receive an array back and will use isGoingOut. And I will, by convention, use set isGoingOut as my function name. Next, I need to make it so that this div, when it's clicked, will flip that value. There's a few different ways I could do this. In fact, I think I'll show you them. I'll set an on-click here, and one way that you may see from time to time is somebody providing an arrow function directly inside of your on-click. One benefit of this is that you can just declare it right here, and it is nice and concise, short and sweet. In fact, I'll start going down this path, and then I'll probably change to move this function into its own defined function outside of my return. But let's go down this road for a second. When a click on this div happens, I want to run this whole function, and the main thing I want this to do is to use set isGoingOut. And now I need to think, do I need the old value of state to determine the new value? And yes, in this case I do. I need to know if it used to be true, then I want it to be false. If it used to be false, I want it to be true. Now think to yourself, when I need to use the old state, what do I need to provide as my parameter to my setter function here? If you said I need to provide another callback function, then you were right. And that's because this callback function will give me the previous version of state that will help me determine the new version of state. And now that I've typed that out, I can see that this is already a little bit crazy. I have an arrow function calling this function, which takes a function as a parameter, and it becomes one too many levels of inception for me. So I'm going to move this to a function out here. Let's call it change mind, and it's going to run set isGoingOut. And then I can replace this all with just change mind, which looks a lot more concise and, to me at least, is a little simpler to read. With set isGoingOut, I'll take my previous version of state. You can call this whatever you want, and we will return the opposite of whatever previous state used to be. Now, this is a little shorthand trick that I've learned over the years. If you did something more like an if statement that says if prev state was true, then set it to false, and if it was false, then set it to true. That's completely okay. This is another instance where a ternary might be useful. We could say if prev state is true, then return false, but otherwise return true. But all of that is a little bit unnecessary because I can simply say just return the opposite of what it currently is. Now, last but not least, I need to change what is actually displaying on my page. Now, if you struggled to get to this point, first of all, I'd recommend going back and reviewing what we've learned, keep practicing until this first portion of what we just did makes sense. But before you do that, I'd also like to encourage you to pause the screencast and see if you can apply what we learned about ternaries and what our current value of is going out is to determine what we should replace our yes with here. So if you weren't able to complete this far, then pause the screencast and try to figure out what we should put here in our H1. Well, we can just put a ternary directly in line by putting a set of curly braces to tell us that we're going into JavaScript. And I can use a ternary that says is going out is true. Then I want you to display yes, but otherwise I want you to display no. And at this point, we should have everything completed. Let's open this app, we'll refresh it, and when I click, it changes us from yes to no. One thing I like about using a Boolean for our state here is that it's a lot more realistic to a real scenario. I could have possibly made things a little bit simpler by just having this be the string yes or no. I would obviously need to change this down here and say if previous state was yes, then change it to no, and if it was no, then change it to yes. But personally, I like the separation, especially if I'm going to use variable names that start with is or has that indicate a Boolean, to just use a Boolean like true or false, and then translate that true or false Boolean value into something that makes a lot more sense for a user to actually see on the page. Again, if any part of this was overwhelming or too confusing, or you weren't able to do this from memory, then I highly recommend going back, reviewing this, trying to do this challenge again. Don't just push forward. But all in all, you are doing a great job. Whether you understood this or not, you've gotten very far. Also, don't forget to take breaks, stand up if you need to, go get a drink of water, and when you feel refreshed and ready, let's keep moving on. Hey, this looks familiar. This is the little app that we used when we were learning about how saving local variables does not update our UI. And now that we've learned about state, to start us off, your challenge is to convert the code below to use an array that's held in state instead of what we currently have with our local variable here. You can just initialize the state as an array with these same two items. And if I were you, I would call the piece of state that you create things array just like we had before, so we don't have to change anything else in our code here. Pause now and work on this challenge. Let's go ahead and create, in fact, I'm just going to reuse what I have here. I'm going to put this into an array and have a setter function that says set things array. And that will equal react.useState, which I will initialize with this array. And well, let's hit refresh. I think this should work just fine. Okay, well, this is showing up. At least that tells me that things array still contains my two items. The last piece we need to fix is making it so that our add item button will add something to our things array. However, the reason that I'm making this video is because there is a small gotcha in here. And that is that it's tempting to want to do something like things array.push. However, I want you to think for a second, what is wrong with saying things array.push? If you remember back, we should never ever directly modify our state. In this case, our state is things array, and here I'm directly modifying it. .push is a destructive action. It modifies the original array, and therefore we would be changing things array ourselves, and this just isn't a good idea. In fact, not only is it not a good idea, but if I try to do it, let me put a test in here, hit save, and add item, you can see that nothing is going to happen here. Okay, so we know we need to use setThingsArray in order to modify our state, which will actually update the user interface on our screen. So let's use setThingsArray. And if you remember back with setThingsArray or whatever setter function I have I can provide one of two options here. Pause and think for a second, what are the two different options that I could put into the setThings array? Well, I can either provide it with, and I'm going to put these inside of angle brackets to show you this is not real syntax. I could either put in a bare new value, completely replacing the old value of state with this new value, or I can provide it with a callback function, and that callback function would receive as its parameter the old version of state, which I can use to determine the new version of state. So now I want you to pause for a second and think, which of these options should I use? Should I use the new value option, or should I use the callback function option? Well, if I just provided a new value, then I wouldn't really be able to add anything to my existing array. I would be simply replacing my existing array. Because what I want to do is add an item to the array, that means that I do depend on what the old version of state or the old array is in order to determine my new array. So I need to provide a callback function here. I'll do this as an arrow function, and I can put in my, let's say, prev things array, or I could simply say prev state if I wanted to. I'll keep it as prev things array so it's contextual. And now that I have gotten us this far, I want you to pause and see if you can figure out what I need to add or what I need to return in this callback function to correctly update my array with the new thing that I want to add. And if you remember, every time we click add item, we want to determine the length of the array and just add thing, space, and then the new length of the array. So it should automatically put thing3 when I click add item. This one can be a little bit tricky. If you spend more than maybe 5 minutes or so without figuring it out, you can just hit play again, and I'm going to show us how to do this. But I do want you to pause and see if you can figure this one out. Another really tempting thing to do at this point is to say prev things array dot push. However, again, this is not correct. This prev things array is still a reference to my existing state, and using dot push on it is not a good idea because that would be modifying state directly. Not only that, but dot push actually doesn't return the array that is modified. It returns the new length of the array. So this would be like replacing all of our state with a number, which would just be 3. So I guess in two ways, this really isn't going to work for us. Remember, I need to return a new version of state. And my state starts out as an array. In fact, my program expects things array to be an array because I'm using .map on it. So I need to make sure that when I'm setting a new array that I return a new array. This is a new version of state. Fortunately, with ES6, there's a really easy way for me to spread in my existing array, which I have access to with prev things array, which by itself would get me an array of everything that used to be in there. So this is not yet updating it. However, I can very simply add a new item to the end of my array. These are strings, but I'm going to be using some JavaScript to determine the array length. So I'll use some template strings here, and I'll say thing, space, and then interpret some JavaScript by saying prev things array dot length. And because that's the previous array and it's not 0 indexed, and I want this to say 3, I'm going to add 1 to it. In other words, my previous array was 2 items long, and I want it to say thing space 3, so I'm adding a 1 at the end. This is getting a little long, so I'm going to put this onto the next line, which means I then have to use a return. And well, let's just see if this works. I'll hit save. Add item. Awesome, look at that. We've got things adding to our list with the correct numbers and everything. If you're feeling hazy or forgetting the array spread operator and how this works, that's totally okay. Although I would recommend that you go study up on the array spread operator because it's so useful. You're going to find yourself using it all the time, especially in React. However, this isn't the only way to do this. There certainly are other ways to make a copy of our original array or to return a new array. We could even use a for loop that loops over this array and pushes those items to a brand new array. Then we add our string here at the very end before we return that whole new thing. Obviously, this is why I'm saying you should just go focus on learning the array spread operator because it's extremely useful. Okay, I do have one big challenge for you. Okay, it's time to put all the knowledge that you've learned lately together into this challenge. In fact, if you want an extra challenge, you could delete this line where we set up things elements where we're mapping. I figured because it's been a minute since we've looked at this, I wouldn't necessarily make you do this, but if you really want to challenge yourself, you can delete line 13 here and try to do everything completely from scratch. Like I said, I'll leave this here just in case that's a little too much to bite off at this time. So see if you can build this all again from scratch. Let me refresh this so we start from a new spot. Of course, this is broken because some of the values are missing. Pause the screencast and see if you can bring this back to a working state. Okay, let's do this. I'll use things array and set things array as the values I get back from react.useState. I'll initialize my values with thing1 and thing2, and I need to spell things right. Then we will use set things array using the previous array. I could say previous things array or previous array. Maybe this time I'll be a little more generic and just say prev state. And this will return a new array that has all the items from prev state, as well as a new item which says thing space and then the number of prev state.length plus 1. Of course, if I leave this on the same line, I don't need to open curly braces and use the return keyword. Just in case this is bleeding a little bit long for anybody, I am going to put it back that way. And hopefully this didn't drive too many of you crazy. You can see I refresh and everything comes back. I also had taken this on click out. Sorry if that threw anybody for a loop. I'm going to add it back in and say when the button is clicked, I want you to run add item, which will run the set things array function and do all the stuff that we just typed in there. I'll hit save. Awesome, we're working again. I really hope that you attempted that challenge. I know that might have been difficult, but truthfully, that's where the learning happens. You won't be able to truly internalize these things that we're learning unless you put your hands on the keyboard and really challenge yourself. In fact, I would say that as you come to challenges in this course and really any course on Scrimba, if you don't immediately know the answer, don't just hit play. Go to Google, ask the community, go back to previous lessons in that course. Do whatever you can to try and figure it out on your own. And then, of course, if you are completely stuck, you can always hit play. In the next cast, we're going to see something similar, but working with objects in state instead of arrays in state. Now let's see what it looks like to use an object in state. Here we have a simple contact card. It's got a first name, last name, phone, email, and a property called isFavorite. To kick us off, I want you to see if you can figure out how you might fill in some of these values below instead of using the hard-coded values, using the properties from state. Of course, they will look exactly the same because I just copied and pasted these values from the state up above, but you can always test it by changing one of these values in state and seeing if it reflects on your card there. Pause the screencast and work on this challenge. Let's start with the name. We have the first name and last name together inside the same H2, but they're separated in the state up here. The simplest way to do that is simply to put the first name in its own set of curly braces, put a space, and then the last name in its own set of curly braces. Now, because my state is an object, I need to reference the entire contact and then use the dot syntax to access its properties. So I will say contact dot first name, and then the space, which will be interpreted as an actual space in the markup, followed by contact dot last name. Hit save. Nothing looks like it changes. That's good. If I change this to Jane, our contact changes. Great. And then I can simply do the same thing for these other properties. This is contact.phone and contact.email. Now, I mentioned that we're going to ignore the isFavorite property for now. I have another challenge that I'm going to type out now. You might notice in the images that we have two separate PNGs, one called star empty PNG and one called star filled PNG. Right now we're just using the star empty PNG, but if this were filled, and let me comment this out so it doesn't break our code, you'll see that it fills in the star nicely as if this contact were a favorite of yours. However, following the declarative nature of React, we want the isFavorite property to be the determining factor as to which of those two images gets used. So your challenge is to use a ternary right here in this line, I'll uncomment this now, to look at the contact.isFavorite property and determine which of the following file names should be used based on the value of the isFavorite property. Then you'll want to use that star icon value, which will just be a string here, to figure out what the source should be for the star image. In fact, I'll add that to our challenge. Okay, best of luck. Pause the screencast, work on this part of the challenge. On line 21, I'll replace this comment and we'll simply look at contact.isFavorite. I technically could equate this to true or false, but because it's already a Boolean, I just need to say contact.isFavorite. If so, I want to use the star filled PNG, and otherwise I want to use the star empty PNG. And now that I have a value for star icon, I can simply replace whatever is here with star icon. You'll notice I had put backticks here to begin with just to make things a little easier. That's because I knew you were going to be putting in an interpolated value like that. I'll go ahead and hit save. Everything looks the same, but now if I change my isFavorite from false to true in the hard-coded initial value, we get a little filled star. Now that we've learned how to apply state that's in the form of an object to our actual markup, in the next screencast, let's learn about how we can update state when state is an object. Our goal is to be able to click the star icon and have it flip our isFavorite value from true to false or false to true. However, currently our isFavorite property is nested inside of this object. When I call setContact, I need to provide a new version of state to replace the old version. However, in our case, I don't want to replace any of this other information. I only want to change the isFavorite value. Many people's first thought is to use setContact, and here you'll see I already have set up a toggle favorite function, which is called anytime the little star icon image is clicked. Right now it's just console logging toggle favorite. A temptation is to use setContact, look at the previous contact information, and return, and I guess for simplicity I'll put this on its own line, we'll say return an object where the isFavorite property is the opposite of the previous contact's isFavorite property. However, there is a major problem with doing it this way. I'm not going to hit refresh yet, but I do want you to pause the screencast and see if you can figure out what mistake I have right here. Remember that in this callback function, whatever I return from that function will become the new replacement for our contact state. Currently, I have an object with 5 properties, first name, last name, phone, email, and isFavorite. But what I'm replacing it with is an object that only has one property, isFavorite. So if I hit save, and then click our toggle favorite, you'll see that all of our other information just disappears. However, it does look like our star is working. I can click our star and it is correctly flipping back and forth, but obviously this is a bug. If you do happen to be coming to this course having had experience in class-based React, this might seem confusing to you. If you've never worked with class-based React, you can ignore the next thing I'm about to say. But in class-based React, when you use this.setState, it would automatically figure out how to combine your old object with the new property that you're trying to replace it with. However, using hooks with React.useState no longer does this. Okay, everybody can tune back in now. The main point is that I need to make sure that I bring in all of the properties of my old object and then replace the 1 or 2 or however many properties you need to replace in what you're trying to accomplish. A very simple way for me to do that is to spread in all of the properties of my old contact. And in this case, I have access to the old contact using priv contact. So I'll bring in all of the properties, and this, by the way, does include the isFavorite property, but then I will overwrite the isFavorite property with a new value. In effect, it's like taking this whole thing, copying it, pasting it in, just like this, where we have our old first name, old last name, old phone, old email, the old isFavorite, and then we're saying, actually, I want a different isFavorite. Believe it or not, this is not a syntax error. Instead, it just takes the second one that's declared, or rather the last one that's declared, and uses that as the actual value for our new object. This is much more verbose than it needs to be, so I will use my spread operator instead like I had before. I'll hit save. Notice this is filled in because my value is true by default. I should probably set that to false by default. And then when I click it, all of the other information stays the same except for the value of isFavorite, which is then redetermining which icon is going to be used based on that contact.isFavorite property. I totally understand that this can be complex. This was one of the more difficult things that I had to grasp when I was first learning how to do state in React. So to see if you were paying attention, this is your time to shine. Your challenge is to simply rebuild what we just had. Again, if you get stuck and you don't remember the syntax, don't just hit play and watch me do it. Open a new tab, do a quick query on Google, see if you can find a resource that will help you figure this out, or even go back earlier in the screencast and see how I did it so that you can then come back to this point and type it out yourself. So pause the screencast and see if you can rebuild our toggle favorite function. Okay, let's do it. We're calling setContact. We do care about the previous value of our state in order to help us determine the new one, not only because we need to know what the value of isFavorite was, but also because we want to make sure we maintain all of the other properties. So in that case, I'll use my callback function. I'll let it pass priv contact to it, and I will use that to return a new object. And here's actually a quick aside. It might be tempting to say, well, I just want to use the implicit return and say, take this function, return an object. However, these curly braces are being interpreted as the opening part of the function body. If I do want to literally return an object, I need to surround my object with another set of parentheses. This looks a little bit crazy. Maybe just to show you that it works, I will leave it here, and for brevity, I suppose. So given our previous contact, I want to return an object that has all of the values of our previous contact, but changes the isFavorite value to the opposite of whatever it currently is. I'll hit save. It's empty by default because isFavorite is false, and I can toggle that on and off. I hope that challenge went well. If you felt like it was a struggle, then of course, as always, you can go back and try it again. As I've always said, the easiest way to learn something new is to do it the hard way. And I imagine some of you out there, when you saw me delete all of the code inside of here, maybe had a little panic moment and you thought, oh no, he's going to make me do this by myself. But your growth in understanding of React will only happen as you type this stuff out yourself. Watching me do it alone is not going to help you learn it. So as always, once you feel comfortable enough that you could write this out again all by yourself, that means that we're ready to move forward. When we last left the meme generator, we were getting a weird unknown error being thrown from React. I looked into it and I realized that it was because we were initializing state as an empty string and React was not taking too kindly to having our image source set as an empty string. So I just went and grabbed a placeholder image for now, and that seems to have gotten rid of the error. Just thought I'd give you a quick update on that error. Our challenge in this screencast is to update our state so that we can be well prepared as we learn more to save that state and ultimately finish our meme generator. So your challenge is to create an object in state. We'll call it meme, and it should have a property for the top text, bottom text, and the random image that we choose. You can default the top text and bottom text as empty strings, and I would default the random image to the string that I have below so that we don't get that same error we had before. Next, I want you to create a separate state variable called allMemeImages. This allMemeImages variable is going to hold an array of all of our memes data, which for now you can default to the memes data array that we imported up here. Then lastly, you'll want to update the rest of our code to use these new state variables so that in the end we have a working app the way that it's currently working. So pause the screencast and work on this challenge. Let's comment out our old state here, just so we don't get confused, and we'll create some new state with meme and set meme equal to react.useState. And this one's going to be an object, so I'll put my curly braces, and we'll put in our three properties. We have top text, which is an empty string, bottom text, also an empty string, and random image, which will be the same as what we had before in our old meme image state variable. Then we need another state variable, so we'll create a new one. We'll say this is all meme images, and we can say set all meme images as our function here. React.useState, and the initial value is going to be our memes data array that we imported above. With those set up, we really just need to update the rest of our code. So anywhere I was directly accessing memes data, I'm now going to use all meme images. And then we have a bit of a gotcha here. Before, when we were just saving the meme image as a string, we were able to just completely overwrite whatever the old string was and replace it with the new URL. However, now the random image, which represents our new version of meme image, is nested inside of an object. So first of all, we need to use set meme instead of set meme image. And instead of what we had before, we do need to look at what the previous meme was in order to determine the new one, because we have properties like top text and bottom text that we don't want to lose. I think I'm going to save this as its own variable. So I'll say URL equals the memes array at the index of random number.url, just to make my life a little bit easier. And now I'm going to access the previous meme and return an object. I'll surround it in parentheses so I can use my implicit return. We'll pull in all of the properties of the previous meme, and then we will alter the random image property to be our URL. Let's scroll down and see down here we have onClick get meme image. That's still going to be the same because that's our self-defined function. However, here instead of meme image, we want to say meme.randomImage. And let's cross our fingers. We'll hit refresh. I can click get a new meme image, and awesome, we're working just the way we were before. Obviously, our top text and our bottom text is not yet doing anything, but we're first going to have to learn about forms and inputs and how to save state, which will be happening later down the road. All right, awesome work. Let's keep moving forward. At this point, we've learned to use a number of really cool tools in React like state and props. Now we get to start using those tools in creative ways and putting them together. Your challenge here is honestly pretty contrived. I can't think of a reason why you would actually want to do this, but for the sake of practice, I want you to create a new component named count, which will essentially replace these three lines of code. In other words, you'll create a new component named count. It will render this div with this h1, and in an effort to practice props, we're going to pass that new count component a prop that we'll just generically call number. The value of that prop number should be the value of our current count. I promise this isn't just busy work. We are building toward a point. Pause the screencast and work on this challenge. Okay, I'm going to do this working backwards. So my div here, I'm going to cut this, but keep it in my clipboard so I can paste it later. And I'll render a component called count, which I obviously haven't yet created. We said we're going to pass to it a number prop, and I'm going to set that equal to the current value of my count up there. Now I need to import it if I'm going to use it here. Obviously it still doesn't exist, but we'll just pretend it does. So I'm going to import count from a file called count, and then I need to create that file and work over there. So I'm going to create count.js. Import React from React, and I'll just spin up my basic component here. called count. And I need to make sure that this is receiving props because I'm going to use that number prop. I'll have it return, and then I'm just going to paste that div that I had before. Okay, and now it doesn't have a count variable anywhere in here. Remember, before this was referencing the state value of count, but now I'm receiving it through props. So I can say props dot, and it's not props dot count because the prop we passed to it was called number, props dot number. I'll hit refresh, and you can see everything is working exactly the way it was before. Now, as I mentioned, this is pretty contrived. I can't imagine why you would care to put a count component in its own component that just displays a number, especially when it's only 3 lines of code, unless for some reason you are going to be reusing this component in different contexts around your application. Let me clean up this challenge, and then we'll talk about why I had you do this. As I've mentioned, we've learned how to use props for a component to be able to receive values like we've done here. And we've learned state and how to have a component declare its own values that are intended to change and update the user interface when those changes happen. And now all we're doing is we're combining those two concepts. We are still initiating state inside of our app component, but then we're passing that state value down to a separate component called count, and it's receiving that value as props. Now we're going to see something cool that React does. Let me, inside of my app component, console log app component rendered. Anytime React creates an instance of our app component, which is happening here in index.js, it will run this function, and part of that function will console log app component rendered. Then we'll go ahead and do the exact same thing in the count component. And we'll change this to count component rendered. Now, before I hit refresh, as a reminder, the word rendered simply means that it placed the elements that React knew it needed to place on the screen. So when I say app component rendered, it means that it took the markup of our app component and it painted it to the screen, or it placed it on the screen. It created the DOM elements and the styles that it needed for it to display correctly on the screen. And you can see there's a sort of cascading effect here. Over in index.js, we render an app component. When we go to app, we see that it renders a count component, and it's doing that down the line. So it will first say app component rendered. I'll open the console and hit refresh. We see app component rendered and count component rendered. Now there's a really cool thing that React does for us, and that is whenever state changes, it will re-render the component where the state exists and any child components that may rely on state to be working correctly. And if you think about it, that makes sense. If I'm going to change my state from 0 to 1, I'm going to need my component here to re-render, which will then cause this count component to re-render, and it will pass the new value of count. And that way it can very quickly and seamlessly update what I see on the page just by re-rendering those components. We're not going to dive deep at this point into understanding exactly how React is re-rendering, which components it's re-rendering, and optimizing which components it's re-rendering. That's a topic for a more advanced course. But for now, it's a good experiment to have these console logs here and see that every single time we change our state, it's re-rendering the component in which the state is declared and any children components like our count component here that may or may not depend on the state value for count. Awesome. Now we've seen an example of a child component receiving a state value via props. Now we'll look at how a child component might be given access to make changes to its parent's state. Okay, here we are back at our little contact card with the favorite icon. Your challenge to start us off is to move the little star image, just this one little image element, into its own component, and maybe we'll just call it star. That'll be the name of the component. And it should receive a prop called isFilled that the star component will use to determine whether the icon should display the filled PNG or the empty PNG. Then inside of this component here, you'll need to import and render the new star component and make sure to pass the correct value of isFavorite, our contact.isFavorite, to that isFilled prop. At this point, it's not going to work the way it was before, where we could click it and flip it on and off. For now, in order to test it, you can simply change this value from false to true, and it should, if it's working correctly, display the filled in star when you change that to true. There's a few different moving pieces here, so this is a slightly more difficult challenge than the ones we've done up until now, but I know you'll be able to do it. Pause the screencast now and start working on this challenge. Once again, I think I'll work backwards. I'm going to cut this image out, and I will render a star component, which I have not yet created. I'll give it this isFilled prop, and it will be the value of contact.isFavorite. Let's import this, and then we'll go and create it. So I'll import star from /star, and then I'll create that file star.js. Okay, and in this case, I need to make sure that I'm receiving props because I will need them. I'm going to return and then this image element. I'm going to get to this onClick in just a second, but for now, let's figure out our star icon. I'm going to just set star icon equal to, and then I'm just going to go take exactly what I had here and then make a slight change. Okay, now we don't have access to our contact state because we're not passing it down. However, we do have a replacement isFilled, and that's part of props, so it's props.isFilled. And then this will determine which image should be used. Let me remove my onClick so I don't get an error. We'll hit refresh and see if we missed anything. Okay, awesome. Now my star is empty, and that's because this value is false. Let's test this by changing it to true. And the star is filled. Awesome. And at this point, I can remove this line because I'm not needing that anymore. And at this point, that leads us to the topic of this screencast, and that is, how do I make it so that I can change this value? Clicking it is not doing anything. The conundrum that we have is that we have a child component that's receiving the value of isFavorite through props, but it is not receiving the ability to change that state. So think for a second, how can I give my child component the ability to make changes to the state that lives inside the parent component, which is app? In fact, I want you to pause and try to think through a solution to this. You don't actually have to type it and try it out, but just try to think, how could I give my child component the ability to make changes to the state that lives in the parent? One thing that can be tricky when you're first learning React is the thought that you can just add a click event listener on your star component. So what if I just said onClick equals toggle favorite? Let me hit refresh and click this, and you'll see, well, it's not quite working. Why do you think that this isn't enough for this to work? Remember, when we have a component that we created, a custom component that we created, all of the properties that we pass it are custom properties. So simply putting onClick here doesn't magically register it as an event listener. The onClick attribute needs to exist on native DOM elements like these ones that begin with lowercase letters. That's because these are what will actually get created into real DOM elements by React. However, star with a capital S is not a real DOM element. Instead, what's happening is React is looking at the star component and it's rendering this image. This image has the ability to receive an onClick event listener. So what I could do is still pass onClick here, but realize that onClick is just a custom prop that happens to be called the same name as the event listener. In fact, oftentimes this will be changed to handleClick just to make it very obvious that it's not a native event listener. And then over in our star component, I can add a real onClick event listener and say the value of this onClick will be the function that comes from props.handleClick. In this case, my app component is passing this toggle favorite function to a child component and allowing that child component to run it whenever a certain event like the click event happens. However, it's important to note that the context in which the toggle favorite function exists is still here in the parent. which means that it can change the state that lives inside the parent. Let's hit refresh. We'll click our star and we see that we're back to working the way we thought. So as a recap, we created our toggle favorite function. We passed it to our custom component in a custom prop called handleClick. And then over in the star component, it's receiving props and it's registering a real event listener onClick whose functional value is the function that we received through props.handleClick. The ability to pass state setter functions like this one down to children components is especially crucial in React. And that's due to the fact that the way that React's hierarchy is set up when it passes data. And this is what we're going to talk about in the next lesson. At this point, I think it's worth taking a high-level look at how data is passed from one component to another in React. Let's imagine we have a fairly simple app which has the following components, just represented by rectangles for now. In this tree, this top component represents a top-level component, for example, our app component in a system set up like this. And the lines indicate that this top component is rendering these other components. In some cases, that component may just render regular DOM elements like divs and h1s, or it may render additional custom components like we see in this box where it's rendering two other components. I didn't put any names on here because that's not that terribly important. The point is that there is a parent-child relationship between these components. Let's imagine on one of these bottom-level components we initialize some state. And then we find that a sibling component, in other words, a component that is also rendered by the same parent, is in need of some of the data that lives in the other component's state. Well, what exactly can we do then? Think for a second, is there a way for us to pass that state to a sibling component? It turns out that no, this is not possible. And that's because if you look in the file of a component that has a sibling component, it has no reference or knowledge about a sibling component on its own. If we look in our code here, we have an app component that is rendering a header component and a body component. But if we were to go into, let's say, the header component, we see that I've initialized some state here. I can open up this preview so you see what we're working with. And it's using that state. But then if a sibling component like the body needs access to that state, well, the header has no idea that body even exists. Only its immediate parent, app, is the component that knows that both of these components exist. So think for a second, what is it that we need to do if we're facing a situation like this? Well, what if we took our state in this child component and we raised it up into the parent component? Now that it's up in the parent component, do we have a way in React to pass data from this parent component to the child components? Yes, we do. That happens through props. So now the parent component is in charge of the state. It passes the necessary state down to the child components that require it, and they can simply consume the state. If that state were ever to change, React will update this component where the state changed, and it will also update any children components as well. And so therefore, if that state changes that's being passed through props, the child component can update as well. As your application gets more and more complex, you will find yourself having another component that sometimes needs access to that state as well. And just like before, there's no way for us to pass the state or any kind of data from one sibling component to another component, but it's also important to note that there also is no way to pass data upwards in React. This child component has no idea that this other, I guess you could say, uncle or aunt component exists, and therefore there's no way to pass data that way either. So this brings us back to the same solution we had before. We simply raise state up a level, and we pass more props downward. Now, over time, this can get pretty tedious, especially if your state ends up raising up multiple levels above the component that needs it, in which case React does offer a solution to this called context. There's also third-party state management systems like Redux that can help solve this problem. However, both of those are beyond the scope of this course, and we are just going to be sticking with regular state and props for now. So that leads me to a challenge. I I want you to take the state that currently exists only within the header and raise it up a level into the app component, and then pass it back down through props to both the header and the body. Then in the body, now that it's receiving the state from above, replace this underline with the state, which is the name of the user. Pause the screencast now and work on this challenge. To raise the state up, we'll simply take this line where we're initializing our state, and we'll move it into our app component. And then I will pass those props down. In this case, it's a very simple state of just the string Joe. So we will create a prop, maybe let's just call it user, and we'll set that equal to our user state variable here. Then in both the body and the header, we'll need to accept props, and we'll display props.user, and in the header, props.user. Clean up this challenge, hit refresh, and there we go. Now if I go to my app and I initialize my state differently, say Bob, and good, it updates in both places. Understanding that this is the way data flows in React can be really crucial in helping you architect your application in a way that you can share state amongst only the components that need it. And in fact, that's an important distinction to make at this point. It wouldn't be a great idea to initialize state way up near the top of your component if you don't have components along the entire tree that need it. Now, I'm not saying that every component needs to have access to that state for it to work, but if this component down here is the only one that needs state, there's no reason for me to put state in its parent or its grandparent and then pass stuff down through props. As a rule of thumb, keep state as local as you can, or in other words, keep it as closely tied to the component or components that need it as you possibly can. With this under our belts, I think it's about time for us to jump in and do a round of challenges to really exercise what you've learned up until this point, and we will start that in the next screencast. This is the beginning of a series of small challenges to really reinforce some of the past topics that we've been learning about. The first thing I want you to do is to take a look at boxes.js. You'll see I created an array of objects which have two properties, ID and on. And your first challenge is to initialize some state inside of our app component with the default value being this boxes array. And then I want you to map over that state array and display each one as just an empty square on the screen with a black border and a transparent background color. I don't think you necessarily have to set it as transparent. I think it'll just be transparent by default. For now, don't worry about using the on property at all, although you probably will want to use the ID property, and I'll let you figure out why. If you're using something like a div, don't forget to set a height and a width in the style on it. Ultimately, the goal is to make it so that if the box is set to on or on as true, then the box will be filled in with a color. And in the end, we'll make it so that clicking the box will flip its on value from true to false or false to true. But for now, let's just get some boxes displaying on the page. Pause the screencast and work on this first part of the challenge. We'll start by initializing some state. So I'll say, I don't know, maybe for now we'll just call them squares. And by convention, we'll say set squares. That's going to be from react.useState, and we'll pull in the boxes as the initial value. Then we need to map over the boxes. I'll save my array of elements. I'll maybe call it square elements. And that's going to be squares.map. For each square that we're looking at, I want to return a div. And notice here that I'm using parentheses instead of curly braces. That's simply allowing me to use the implicit return to return the element, and I'm just moving it onto its own line so it doesn't go too far to the left and right. We'll give this div a class name. Let's call it box. And actually, this is a class name, so it can just be the string box. I also know because I'm mapping that I'm going to run into that issue where I need to provide a key. In this case, I can use the ID property that's coming from each of these objects. Let's display our square elements and then we'll go into the style so that it will actually show up. Or rather, I should say, let's render our square elements. I don't think they are going to look like anything on the screen. Yeah, it's just empty. Over in our style, we'll set a style for box and we'll give it a height. Maybe we'll do 100 pixels and a width of 100 pixels. We'll give it a border that's black. And then maybe just so we can see everything, I'll put these into a really simple grid just so that I can put them side by side a little better. Actually, I might not even bother with that. Let me give these a display of inline block, and I'll just put a little bit of margin right on them. Honestly, this is going to be good enough for right now. And awesome. Okay. The main things that I wanted you to take away were to practice setting state or initializing some state, and also practicing the .map method to create an array of elements that we can display on the page, as well as reminding you about this key property. If I take this out, I'm going to get that warning that React always gives if you use a .map to create elements but forget to add a key prop. So I will put that back in. Awesome work. On the next cast, let's do the next part of this challenge. Before we can do the next challenge, we need to learn about the style prop. You might be familiar with the concept that in HTML, I can add an attribute called style, and in here, I can insert CSS code. For example, I could give my div with the ID of root, or actually, you know what, let's do this on the body. I could add a style and say the background color is black. Hit refresh, and sure enough, my entire background color becomes black. Just like I can do this in HTML, I can do the exact same thing in React. However, because it's React and it's JavaScript, I can change the style dynamically depending on, for example, the value of our state or the value of incoming props on a component. Let me refresh this so we get our boxes back. And actually, I think I might just add a tiny bit of border radius to those boxes. Okay. To add dynamic style, I can add a style prop to my div. And in React, I'm not going to put a string the same way we did in HTML. Instead, I'm going to provide an object. Now, here's something that really confused me the first few times I saw it. This set of curly braces does not represent an object. It simply represents me entering into JavaScript outside of JSX, or rather it allows me to put JavaScript inside of my JSX, as we've learned before. Since I need to represent my style as an object, I'm going to put a second set of curly braces. This inner set of curly braces represents an object, a JavaScript object, and this first set of curly braces, or the outside set of curly braces, represents me going into JavaScript from JSX. Oftentimes, to avoid any confusion, what I'll do is I will not define that object directly inside of my markup, but instead I will create a separate variable, maybe called styles, and set that equal to an object. This makes it a lot more clear, and I can just put styles directly inside of my markup here. One thing to know about these styles is that they need to be camel cased. So if I'm changing the background color, I can't say background-color because this is not a valid key name in a JavaScript object. Not only that, but when I'm modifying the properties of a DOM element, you might remember that I could do something like document.getElementById, we'll say some kind of ID, and I can say .style.backgroundColor with a camel-cased property name and set that equal to something. Essentially, that's exactly what we're doing here. We are setting the style attribute of our DOM element to be an object, hence I can use the dot syntax here, and then I'm using the background color CSS property, but of course in the camel-cased version for JavaScript. Then because this is an object, I'm not going to use the equal sign, I'm going to use the colon to give my key a value, and I don't know, let's set it to black for now. Let me get rid of this equals so that, actually let me get rid of that whole line since I don't want to be doing manual DOM JavaScript here. Oh cool, look, I refreshed. My styles, which include a background color of black, are now being applied as the style of every square that I'm rendering, or every div that I'm rendering. So why is this beneficial over just using CSS? Well, because I'm using JavaScript, I don't necessarily have to have a hard-coded black value here. Let's suppose for a second that my app component is going to receive a prop that's called dark mode. In fact, let's go over to index.js and we will say that the app component is receiving a prop called dark mode. And let's set it to true for now. Over in my app, I'm accepting props here, and I will have a prop called props.darkMode. And let's say that if my props.darkMode is true, I want it to be black, and if it's false, I want it to be, I don't know, something light. Well, this is something I can use a ternary for, and maybe I should be more specific. This is something that you can use a ternary for. Using your knowledge of ternaries, make it so that if props.darkMode is true, it will set the background color to this hex value here. And if it's false, it will set it to this hex value here. One important thing to note is that these values need to be strings because we're in JavaScript, we're not in CSS. Pause now and work on this challenge. Let's take props.darkMode and we will put it here. And I'll say if that's true, then I'm going to use this string. And if it's false, I'm going to use this string. And it looks like I might have deleted my curly brace there. Okay, awesome. Now we can test this by simply changing my dark mode value from true to false. And awesome, look at that, it worked great. This can be a really fun one to play around with. If you'd like, you can pause and just play around with some of the other properties that we can change in the styles. Or you could try a little challenge of your own to see if the number of squares in this array is even, then make them all one color, or if it's odd, make them all another color. Really, your imagination is the limit here. When you're ready, we will move on to part 2 of our original challenge. It's time for part 2 of this challenge. I want you to move our div here into a separate component called box. And then when you're mapping over our squares, you will render that box component. That box component should receive a prop called on, and it will be the value of this square dot on. From our original boxes.js, each one of them has an on property, and that value is what you're going to pass to your new box component. Then inside of that box component, I want you to create a dynamic style like we did in the last screencast to determine the background color of the box. If the box is on, then you should set the background color to this hex value. And if it's off, you can just set it to the string none. Pause the screencast and work on this challenge. Let me create a new file called box.js. I'll set this up like normal. I know that this component will be receiving props, and I'm just going to copy this div and have that get returned. Now my key is going to be broken, and actually I'm going to pass this key into the box component. So let's go ahead and render our box component, which will be self-closing. This class name is already handled on the div that box is rendering. However, I will keep the key right here. The next part says to pass it a prop called on. So I'll say on equals, and then the value will be square.on. Again, each square here represents one of the objects in my array, and that has a property called on. Let's just make sure that everything is working so far. In my box component, I will console log props.on. And because I have 6 instances, I should get 6 values here. Oh, and of course, I did not import my box component, so I need to import box from box. Okay, let's try that again. Awesome. Okay, so I get my 6 values, true, false, true, true, false, false, and that's matching perfectly with what I see in my data here. Then the last part of this challenge is simply to make use of props.on to determine what the hex value or the background color should actually be. So using dynamic styles, I will create a variable called styles, and that's going to be an object where the background color is going to look at props.on, and if it's true, it will be this dark color, and if it's false, it will be none. Then I can simply add a style prop. Notice that my variable is called styles. You really can call this whatever you want. However, this attribute or this property needs to be style exactly that way. So I'll set that equal to the object that I created above. And I think I should see this one is dark. It was true, false, true, true, false, false. So this one should be dark, this one, and this one should be dark, and the rest should be clear. And that's exactly what we get. Next, we're approaching probably the most challenging part, and that is where clicking the box will actually flip the on value from true to false or false to true. I'll give you some hand-holding in that challenge, but honestly, it's going to be a pretty fun one, so that's what we will work on in the next lesson. In the next two challenges, we are actually going to be starting to dip our toes into some intermediate React topics here. The concept of changing state is what we have been practicing this whole time. However, we're going to see two different ways that we could structure this project and talk about which one is going to be the better of the two. I put together a little diagram to make this a little simpler to understand. Right now we have an app component, and this app component is keeping track of an array of data. We're then using that array to create box components for every item in that array, and passing to those box components a prop called on, which will have the value either true or false. Currently, those box components are then taking this incoming prop and determining what the background color should be. However, at this point in time, they have no way to modify that incoming prop. Keep in mind that in reality, a component should never modify props. In other words, my box component should never say props.on equals something different. However, we do have some ways that we can still make changes to the background color of our box, and that's what we're going to be talking about. The first way we're going to see is to initialize new state in each one of these box components and set its initial value to the incoming props.on value. One benefit in doing it this way is the simplicity in allowing each box to then update its own state. Of course, by doing so, automatically every instance of our box component will also have the ability to update its own state. When I first started learning React, this was the most obvious way to allow each of these boxes the ability to flip its own value. And so that's what your challenge is this time. I want you to create some state inside of our box component. You'll determine its initial value based on the props.on value. You'll also create an event listener so that when the div of the box gets clicked, it can flip the value from true to false or false to true. While you're at it, don't forget to update your styles here in this ternary. Currently, it's looking at props.on. You'll want to make sure that you're looking at the local state instead of the incoming value of props.on. And the last thing is a quick change I made. In the previous screencast, I had set this to none, but it turns out this should actually be transparent if I want this to empty out the color. So don't let that be confusing. Okay, this is your time. Pause the screencast and work on this challenge. In truth, this is very similar to what we have already done so far. I'll initialize some new state. We'll call it on, and it will also receive our setter function, which I'll call setOn, by calling react.useState. The initial value should be determined by looking at props.on. I'm going to update this to not look at props.on anymore, but to look at my new state value of on. And that way, when I make a function, let's call it toggle, and it calls setOn looking at the previous version of on and simply giving me the opposite of whatever that previous version of on was, I can then set this up as a click event listener to run toggle. Should be able to clean this challenge up, hit refresh, and sure enough, I'm able to flip the value. Now it's not readily apparent, but keep in mind that what we've done is we've given each one of these boxes its own value of state. So basically, we've given it the ability to control itself. We've given it the control over its on value. Now, I understand the boxes seems a little bit contrived. However, this same concept would apply to something like a to-do list, for example. Our app would be like the to-do list, and each of these boxes would be like a to-do item. The value of on might be replaced with a value called maybe completed as to whether or not that to-do item has been completed. Structuring it the way that we just did here, every item in our to-do list would be in charge of knowing if it by itself has already been completed or not. When I first started writing React, this seemed like the most obvious thing to do. However, I've since learned that there actually is a better way to structure our application so that state is only held in the app component in our example here. There certainly might be situations where creating state in each one of the child components and initializing that state based on the incoming props might make sense. However, general consensus is that if you find yourself initializing state by using the incoming value of some prop, there's probably a better way to do this. And that's what we'll be diving into in the next lesson. Previously, what we did is we created new state inside each of our box components and initialized that state based on the incoming prop of on. And it turns out there's actually a name for when you create state that is initialized by incoming props. And it's called derived state. And I'm sorry to break this to you, but it turns out that you probably don't need derived state. This is an article that was written in 2018. You can click on the link. It's in the React documentation. It will probably get a little bit heavy if you're still a beginner in React, but it turns out that there can be some weirdness that happens if you pass a prop to a component and then just take that prop and set state based on that prop. If you think about it, in app.js, we actually created some state in app.js to maintain all of the squares already. So when we set state in each one of our boxes, we had state both in the app and in every one of our boxes, which in the end means that there are two sources of truth. When the box had the ability to update its own state, it was not updating the state on the app component. It was only updating its local state that it had derived based on the incoming props. And because of that, there were multiple sources of truth. Now, certainly there are circumstances where derived state makes sense. This article does talk about some examples of that. However, it's far less common than I think most people end up using when they're writing React applications. And the whole reason I decided to talk about this in this course is to help you navigate a scenario that, at least for me, was really tricky when I was learning. So we're going to approach this in a different way. Instead of putting state and a setter inside of each one of our boxes, we're going to make use of the state that already exists in our app. And instead, we're going to create a function called toggle inside of our app component, and then pass that toggle function down to each one of our box instances. Anytime one of the box components gets clicked, it will run this toggle function and essentially tell the app component, hey, the state that you're maintaining needs to change. Then when that state changes, let's say this first object gets clicked and it changes from true to false, React will re-render the app component because its state has changed, and therefore will re-render the box components, but now with the first one having an on value of false. You certainly are going to notice that this way of doing things is more complex. However, in the end, it is a better practice than using derived state to manage our state. Because of the additional complexity, I'm going to give you a challenge that has you doing part of this, and then we're going to walk through completing it together. So let's go ahead and get started. The challenge is for you to create that toggle function that for now is just going to log clicked to the console. Then I want you to pass that function down to each of the box components and set it up so that when they get clicked, it simply runs the function, which means it will console log clicked. I've already removed the state from our box component, so that isn't something you have to worry about. Pause the screencast and work on this challenge. Okay, let's create a function called toggle. Simply enough, it's going to console log clicked. Then we're going to pass that function to each one of our boxes. We can choose the prop name we want. Sometimes I'll use what looks like the onClick event handler, but keep in mind that because this is a custom component, it won't automatically register this as an event listener. I think more often I'll choose something like handle click that makes it very clear that I'm talking about handling an event. However, I also could just give it the name of the function. Really, we can do whatever we want here. Let's stick with toggle for now, and we'll pass down the toggle function. And now inside of box.js, I'm receiving a prop called toggle, and this is where it does need to be on click with the capital C. We'll use props.toggle. I'll hit save, and clicking it, awesome, runs the function that we defined. This is the point where some additional complexity needs to be added in order for this to work correctly. When each box was initializing its own state, it was really simple to know which box was flipping its value because, well, each box was maintaining its own state. However, now with our toggle function, the toggle function has no idea which box just ran its code. So in my app component, if I wanted to use set squares, because squares is an array, I need to figure out which of the items in the array triggered set squares so that I can update the correct one and leave all the other ones exactly how they were. And this is where we are essentially forced to do something a bit clever. And I figured at this point it would be better for me to walk you through some examples of how we might solve this problem. Let me clean up our challenge. Our goal is to give the toggle function the ability to know which box was clicked so that we can correctly update the state array. One way we could do that is to make it so that the toggle function takes the ID of the box as a parameter. However, as it's currently set up, this is not going to work. And that's because in our onClick here, we really don't get to decide what parameter gets passed to our function. Every browser will pass an event handler function, the event itself. It's an event object that describes a bunch of information about the event. In fact, I can see that really quick. Here I will, instead of console logging clicked, let's console log ID, which we're going to be disappointed in what actually happens. I'll hit save, click a box, and you'll see I get a synthetic base event, clearly not the ID of the box that was clicked. However, we can work around this by, instead of just blindly running props.toggle, we can run our own function, which then runs props.toggle. This is the function that is going to receive the event. However, we're not going to make use of that, so I'll just delete event. And then this function can run props.toggle, and now we have the ability to pass whatever we want here. In this case, what we should pass is the ID of this box. However, currently we're not receiving that ID. Sure, I have this key prop. However, the key prop really is intended for something completely different, and I'm fairly certain that if I even tried to access that key prop, let's console log props.key, yeah, I'm going to get a bunch of undefineds. I don't have access to props.key inside of this component. But that doesn't stop me from passing another prop, let's call it ID, and it essentially is the exact same thing. Now I do have access inside of box to props.id. So if I console log props.id, I get the IDs of each of the boxes. And now I can use props.id to pass that information, pass the ID to my toggle function. Now over in app.js, if I console log the ID that's coming in, of course this will only run when I click it. Let me click the very first box, and that is my ID of 1. This one should be 2, 3, 4, 5, and 6. Awesome. This is great news because now I can use that ID to update the correct square in my setSquares function. At this point, I think this is something that you'll be able to do as a challenge. This lesson's getting a bit long, so that's what we'll do in the next lesson. I'll admit right now, this challenge is going to be a little bit tricky. Your goal is to use our setSquares function to update the correct square in the array. Remember, we're receiving the ID and we just want to flip its on value from true to false or false to true. However, the trick is to not change state directly. As a hint, you could go back to the lesson on how we updated arrays in state if you need a reminder on how to do this. However, in that lesson, we mostly just touched on adding new items to that array. In this case, we're not adding new items, we are updating one of the existing items. At this point, it might be tempting to use an array method like splice. However, that is going to directly modify your state because splice alters the array that it's run on. So don't let any of that scare you. I really want you to try your very best to do this. If after maybe 20 minutes you're still struggling on figuring this out, you can always just hit play and we will walk through this together. So let's have at it. Pause the screencast and work on this challenge. Okay, we'll use our setSquares function. As usual, we do need access to our old version of squares in order to determine the new value of our squares. So I'm going to say previous squares. And instead of getting really clever and figuring out a way to do this on a single line, I'm just going to open up this function so we have some breathing room to create variables and do whatever we need. In fact, let me solve this in maybe the least clever way I can think of. I'm going to create a new array. We'll say new squares. I'll set that equal to an empty array, and I'll do a very simple C-style for loop. We'll say let I equal 0, I is less than previous squares.length, I++. And my goal here is to look at each square in the array of squares, and if its ID is equal to the ID that our toggle function got, then we will simply flip the on value to the opposite of whatever it currently is. If we are looking at a square that is not the one with this ID, then we'll simply push that to our new squares array. So let's say our current square is the array of previous squares at the index of I. And now I'll say if our current square that we're looking at has an ID that's equal to the ID given to our function, then I'll say maybe updated square is equal to an object that has all the properties of my current square, except the on property is going to be the opposite of my current square.on. And then I have this new object, and I will push that to my new squares array. So I'll say new squares.push updated square. However, if the ID is not the same, so I'll say else, we're just going to simply push the current square to our new squares array. At the end of this for loop, we should end up with an array that looks almost identical to the original array, prev squares. However, one of the items should have a flipped value for its on property. And so we can see this is getting a little bit long, but there's my for loop. At the end, we'll simply return, because that's what we need to do from our set squares function, is return the new value of state. We'll return our new squares array. To be totally honest, I haven't tested this out. Let's hit refresh, see if this works. Oh, look at that. Awesome. Let's walk through exactly what this is doing. Let me clean up my challenge to buy us some room here. Every time I click on one of these squares, it's running the click event handler that we defined here. That click event handler is running the toggle function that it received through props and passing in the ID that it also received through props. That toggle function is taking that ID, running set squares, and running this function to determine what the new square should be. We look at the previous array of squares and simply generate a new array, loop over the previous array, and when we run into the square in our loop where the ID matches the ID passed into toggle, we create a new object that will replace the old object and push that to our array. If the IDs do not match, we just push the current square in its current form without any changes made to our new array, and we return that. By returning this new array, React will update our squares state array, which means that it will then re-render this component, remap over all of our squares, and create 6 new box components, pass the on value, which was the same in 5 of the squares but different in one of them, and then in our box component, it will simply take that prop and determine what the background color should be. All of that seems really complex. I totally understand that, but you can see it's quick and there really is no lag in doing this at all. At this point, we could just move on from this. Let's say it's a feature we're adding to some app we're creating. However, as we've learned, React really adheres to the principle of writing declarative code. What we have here is very imperative. Doing a C-style for loop this way works perfectly without any problem. So if you're happy with this, you can just move on. But I think it might be worth our time to take a look at how we might write this slightly differently using something a little more declarative instead of imperative. So that's what we'll do in the next lesson. I'm not going to bother making this a challenge this time. I think I'll just walk you through how I oftentimes will update an item in an array using a more declarative method instead of using a C-style for loop like we have here. So let me go ahead and just delete everything inside And I think what I'll do is use the .map method to help me create a new array and return that array all in one go. So I can say return the previous squares .map, and whatever I put into my map function here is going to help determine my new version of the array, which then gets returned from my .map and returned from set squares. This is a lot of returns happening all in one, but let's just see how I would do this. I need to look at each square inside of my map, and whatever I return from this callback function inside of my .map is what will get placed at the same index in my original array in the new array that I return. So what if I were to use a ternary that said, does square.id match the ID passed into my toggle function? If so, I want you to return a new object that has all of the properties of square except for the on property, which is the opposite of square.on. However, if the ID does not match, that's my else here, then I can simply return the square. The only thing I'm missing now is the return keyword. I tried to leave it out in the beginning because these two returns can be a little confusing at first. So fingers crossed, let's hit save, and look at that, everything is updating beautifully. Obviously what we have here is a lot more concise in terms of lines of code, but it does require a bit more of an advanced understanding of JavaScript to fully comprehend. In my experience, what I have here is not so clever that other software engineers would not understand it, and therefore I personally would prefer a solution that looks more like this. I would definitely spend some additional time understanding this if this is confusing, but I will walk us through it one more time. Every time box gets clicked, it runs this function, not just props.toggle, but this function that we've defined inline here. That function will run props.toggle. Remember, we did that so we could pass a parameter, a custom parameter to props.toggle, which we decided to be the ID of the box itself. Then if we go over to the toggle function, it will call setSquares, our state setter function, and we need to use the callback function version of setSquares because we do care what the previous array looked like. So we look at the previous squares and we're going to map over those squares. As a reminder, .map returns a new array without modifying the original array that will have the same length as the original array, and whatever we return from the callback function of .map is what will get placed in the same index in the new array as what was in the original array. What we're doing every time we loop over an item in this array is we're checking if its ID matches the ID. This ID here is the ID that we passed into our toggle function. If those IDs match, then that means it is the square that was clicked. If that's true, then I want to replace the old object with a brand new object, which is why I have these curly braces here. And this is crucial so that I'm not updating state directly. This object is going to pull in all of the values of square exactly as it was, but then it's going to overwrite the on value with its opposite. However, if this is not the box that was clicked, then just give me the old square. In this case, because I'm not making any modifications to it, I don't need to create a new object and spread in the old square or anything like that. I can just hand the old square object directly to my new array. Awesome work. I really hope you were able to follow along with that logic. This truly is something that just takes a lot of practice. At this point, one of the very best things you could do is just delete our toggle function completely and try to recreate it from scratch. In the end, this toggle function is the most complex part of what we have here, so that would be a great place to start if you really want to challenge yourself. I did want to show you one other rather clever solution that we could use instead of passing an ID down to the box, and that is that we could just say our toggle function that we're passing down, just like we did inside of our box, is going to be an individualized toggle function, this entire function here. However, we can pass the square.id immediately as we're passing this toggle function down. In essence, this creates something called a closure, where each instance of our box will have its own toggle and it will remember its own ID, which means I can get rid of this ID prop, and over in box, I can change this back to just toggle, or rather props.toggle. If I hit refresh, We can see that it's working exactly like it was before. Again, awesome work. I really hope that as you have followed me in this mini series on setting state and creating this rather silly little app, that you have worked on the challenges that I've given you. If you haven't, it's not too late. Don't just push forward. Go back and work on these challenges. Make sure that you really understand everything that we've done so far. Pushing forward without understanding this is not going to help you. It's only going to make it harder going forward. Spend the time now to really clarify these things. Ask questions in the Scrimba Discord, and then when you really understand it, you can be happy knowing that you are ready to move forward. Okay, well, this might look familiar. This is our joke component from the previous section. And we're going to use this to kick off a sort of mini-series on learning about conditional rendering in React. Using and understanding conditional rendering is very important in React because you will see it everywhere in React code. To start us off, I have a challenge for you. You're going to create some state called isShown. Its value will be a Boolean, and you'll just default it to false. The idea is for it to be a piece of state that will decide whether or not the punchline should be shown in each of these jokes. And then I want you to add a button, probably just right here below the paragraph, that will toggle that isShown value back and forth. Pause the screencast and work on this challenge. At the top of my component, I'll have my state called isShown and set isShown. That'll equal react.useState. The default value will be false. And then we'll add a button. Let's have this say show punchline. Then let's create a function that will help us toggle our value back and forth. We'll just call it toggle shown. And all it's going to do is run set isShown. We do need to know what the previous value of isShown was, so I'll say prev shown. And that way we can return the opposite of prev shown. That'll just flip it from true to false or false to true. And let's add our onClick event listener here to run toggle shown. While we're at it, I'll go ahead and console log the current value of isShown. And when I click show punchline, okay, now you'll notice that it said false, even though I'm flipping it. That's because it first console logged isShown, which initialized as false, and then I called set isShown. If I click it again, I'll see the old value right before it got changed. This console log's not terribly important anyway, so we'll take it out. One of the reasons I use this joke component to help us learn conditional rendering is, well, I used it already as a way to give you a sneak peek into conditional rendering. Since we have a template here already, even though this might seem a little backwards, I want you to make it so that our paragraph here only shows up if isShown is true. Again, you have a template to help you understand how that works, and then once you have that working, we'll talk through the logic and really fully understand exactly what's going on. Let me update our challenge text here. Okay, make it so that this paragraph only displays if the isShown Boolean is true. Pause the screencast and work on this challenge. Well, as we see here, what we did is we surrounded everything in curly braces, and that allows us to put a JavaScript expression in here. In our case, we're going to say if isShown is true and this paragraph. First, let's see if this is working. Okay, all of our paragraphs, our punchlines are gone. And if I click show punchline, awesome, our paragraph displays. Now, why on earth does this work? When you first learn JavaScript, we usually learn about how this AND logical operator, the double ampersand, is used to make sure that both sides are true or truthy. So let's say you have a couple variables. We'll say condition 1, we'll call it true, and condition 2, let's say that's also true. And if you have an if statement that says if condition 1 and condition 2, meaning if both of those are true or truthy, then the code inside, this code, will run. We also learned that if either one of these are falsy or false, so if I change either one to false, this code will not run. However, if we look deeper into how the computer is actually running this code, it can be very enlightening. For example, let me change condition 2 to a console log statement. This is kind of a strange thing. You're not really going to see this in the real world, but it's just to prove a point. We'll say, hello there. Let me open the console, and I'm going to click save, and we'll see that we immediately get the console log running of hello there. Now, let's see what happens if I change condition 1 to false. I'll hit save, and nothing gets console logged. That's because what the computer does is it first checks the truthiness of this first statement, and if it is not truthy, if it's false or falsy, it actually completely skips whatever it sees after the double ampersands. Since it already knows that this condition will not satisfy what the AND is expecting, in other words, for both sides to be truthy, it knows already that it can completely skip whatever it sees here. So we can take advantage of this in React anytime we have an element on the screen that we want to display if something is true, or completely hide or not even render to the page if that thing is false. Here with the setup, we realized that some jokes were just one-liners. They didn't have a setup and a punchline, they just were the punchline. And in that case, we looked at our incoming props.setup and said, if that's falsy, then don't display this h3 at all. Similarly, with our local state of isShown, we can say, I only want to display or render this paragraph if isShown is true. By doing that, we can have a toggle button that when it's clicked will change isShown of this individual joke component to true, and therefore it will display our paragraph. More specifically, when I click this button, React will re-render this component because its state has changed, and therefore when it's running the return value again and determining what should actually be placed on the screen, isShown is now true, and therefore this expression gets run and put onto the page for us. So as a recap, in React, when you have an element that you either want to display or not display at all, using the AND logical operator is a really concise and great way to do that. This challenge is a pretty straightforward one. Based on what you just learned using the AND logical operator, make it so that this h1 will only display if our array of messages is not empty. If this array is empty, then this h1 should not display at all, and we should end up with a blank page. While you're at it, go ahead and fix our little underline for the number of unread messages we have in our array. Pause the screencast and work on this challenge. Well, first let's replace this underline. We can put in a set of curly braces and simply say messages.length. Okay, that's a good start. Now, if we're deciding whether we want to display this at all or not, then we can use the logical AND operator to say messages.length is greater than 0 and display this h1. That way, if messages.length is greater than 0 is a false statement, in other words, if messages.length is equal to 0, then this h1 will simply not render at all. A more concise way might be to just say messages.length and this h1, and that's because the number 0 is considered a falsy statement. However, I think it reads a little better to be explicit and say the greater than 0 there. Sometimes if this line gets a little bit long, you can break it out onto its own line, something like this. And we can test this by emptying our initial state array. And there we go, we have nothing on the screen. Awesome work. Next, we're going to see another method for doing conditional rendering in React. We have a funny UI bug right now. When we click Show Punchline, it shows the punchline, but the button still says Show Punchline. Knowing what you know so far using the AND operator to conditionally render something, I want you to think for a second, how might you change it so that it says Hide Punchline instead of Show Punchline when the punchline is shown? One thing we could do is make a copy of this button and display them at different times. So I'll do my similar conditional rendering and say if isShown is true, then I want this to say hide punchline. And if isShown is false, or if not isShown, then I want this to say show punchline. technically this will work. So it says show punchline and then it changes to hide punchline. However, we can do better than this, and we can do so by using the ternary operator. The ternary is really helpful when you want to display one thing based on a condition or another thing if that condition is falsy. So instead of duplicating our button, I can keep my button here and simply change the word from show to hide using a ternary. Let me show you what that looks like. I'm going to delete the word show, put in a set of curly braces because I want to use JavaScript now, and we're going to use a ternary looking at the Boolean value is shown, and I'll say is shown question mark. Now if is shown is true, then I want the string hide to be displayed at this point in the button. Otherwise, I want it to say show. I hit save. It's showing show punchline, and when I click it, it changes it to hide punchline. As far as conditional rendering goes, probably 95% of the time you will see conditional rendering handled with either the double ampersand or a ternary. Again, the double ampersand is great if you either want something to display or not display, and the ternary is great if you want to choose between one of two things to display. If your conditions are more complex than just having one of two options to display, usually it'll be best just to turn to a regular old if statement as we have seen in the past. You can save a variable for your text and do either a switch statement or a series of if, else statements to determine what that variable should be and then just display it in your return down here below. Since we've already seen what that looks like in the past, I'm not going to cover it now. I mostly just wanted to look at these two methods for conditionally rendering something in React. Now that we've learned that, let's get a quick practice in. Let's do some conditional rendering practice. One thing I've done with our messages app is I changed this to just say messages instead of num messages because, well, that just makes more sense because this is an array of messages, not a number of messages. Anyway, your challenge is to display the correct thing on the page. If there are no unread messages, it should display you're all caught up. And if there are any messages in the array, it should display you have n unread messages, where n represents the length of the array or the number of messages in that array. As a caveat though, notice I put this parenthesis s here. That's not literally the text parenthesis s. Instead, I want you to, if there is exactly one unread message, put the word message there instead of messages. So pause the screencast and work on this challenge. There certainly is more than one way to accomplish this. For example, I could always render an H1 and then use a ternary inside for the text of that H1. For some reason, that doesn't sit quite right with me. I'm honestly not sure why, but I think the way that I would choose to do this is just to open my curly braces, look at the messages.length, and say if that is exactly equal to 0, and here I'm going to use a ternary, so I'll start a question mark. On the next line, this will be what should display in case there is exactly 0 messages. So I'll do an H1 here and say you're all caught up. Otherwise, I'll put a different H1 that says you have, and let me just put the number hard-coded here for a second, unread messages. Okay, I'll replace this 2 with messages.length. And well, let's see where we are right now. I'll hit save. You have 2 unread messages. If I remove the items from the array, you're all caught up. Awesome. At this point, it might be tempting to do some kind of nested ternary here that says if messages.length is exactly equal to 1 and put another ternary as the else of this first ternary. Personally, I think this is nearly impossible to reason about, and so I never do nested ternaries myself. I suppose one thing I could do is just render this s if messages.length is greater than 1. I think that would look something like this. I would put message and then a set of curly braces and put in my JavaScript here that says messages.length is greater than 1 and the string s. Let's just see if that works. Personally, I don't love this solution. I'll add in a couple items here. Okay, we have 2 unread messages, and if there's only 1 item, okay, you have 1 unread message. However, when I look at this, it's not quite as clear as what I think I would prefer to do, and that is to type out the whole word message or messages and use a ternary. Let me show you what that would look like. You have blank, unread, and then I will open up some JavaScript here and say, is messages.length greater than 1? If so, I want it to say messages, but otherwise I just want it to say message. I'm going to put this onto its own line just so we have some extra space. And although this does take up more characters, I think, than what I had before, to me, this is a lot easier if I have a fellow developer who's going to be coming onto this project and needs to understand what I'm doing here. I think this is easier to reason about and understand. As you can see, there are multiple ways to use conditional rendering, and this is the kind of thing that I'm talking about when we say that React is just JavaScript. Just like in JavaScript where there's multiple ways to solve a single problem, it's the exact same in React. Because you're just using JavaScript, like ternaries and the logical AND operator and so forth, you truly could solve this in probably dozens of different ways. Most people will tell you to find a way that is easy to think about in the future and then to stay consistent throughout your entire code base. Let's go ahead and test this before we call it a good solution. And yeah, see, I need a space there, so we'll put an extra space in there. Oh, and I guess breaking this onto its own line might not have worked. So let's just leave it like that. Okay, 1 unread message and 2 unread messages. Awesome work. When you're ready, let's keep moving forward. It's that time again for another quiz. Pause the screencast, click into the editor, type your answers down, and when you are satisfied with your answers, click play and we'll go through the quiz together. Number 1, what is conditional rendering? Conditional rendering is just a way to determine whether or not something should get displayed, or, as we're going to see, what among many choices should get displayed. Unlike a regular HTML page, which will always display whatever you hard-coded into the HTML, with React, we can use conditional rendering to sometimes not display that thing, or to sometimes display one thing instead of another. So conditional rendering is when we want to only sometimes display something on the page, usually based on some sort of condition. Or maybe I should say always based on some sort of condition. So far we've learned a few different ways to handle conditional rendering. When would you want to use the double ampersand or the AND operator? The AND operator is great to use if you want to decide whether or not to display something at all. So, in other words, when you would want to either display something or just not display it at all. In that case, what you put before the AND operator is the condition, and if that condition is true or truthy, then the JSX element that you put on the right side of the AND operator is what will either get displayed or not get displayed based on the condition of the thing on the left of the AND operator. Number 3, when would you choose to use a ternary? Where the AND operator is great for deciding to display or not to display something, a ternary is great for deciding which among two things you want to display. Technically speaking, you can nest ternary operations inside of other ternary operations, but personally, I highly recommend not doing that. If you find yourself needing to choose between more than 2 options, you probably should just be using regular conditionals with if, else if, and else, or possibly a switch statement. And, well, I guess I just answered number 4. So if you do need to decide between more than 2 options, you should use a regular conditional statement using if, else if, and else, or a switch statement. There's one slight difference between the and ternary and what you can use with an if, else if, else block, and that is that the and the ternary can happen directly in line inside of the returned elements of your function, whereas with the if or else if or the switch statement, those will have to happen outside of the return of your function. So if I have a functional component, let's say it's app, and I'm returning some kind of UI, the and the ternaries can happen right here in line. So I can have something and some JSX. Or I could use a ternary that has the condition and the ternary, and then an else inside the ternary, which is some other element. But if I need to use an if, else if, and else, or a switch statement, I can't do my if inside of the JSX directly like this. Instead, I need to go up above. I can set a variable and then use my if and else if and else block to set some variable to some kind of JSX. I won't type out the whole thing, but that allows me to then just inside of here display some variable, because previously in my if statement it was determined which JSX element it should be. Great work on this quiz. We still have a lot left to learn in this section, so let's keep moving forward. We're going to spend a fair amount of time talking about how to manage and deal with forms in React. From the outside, this might seem like a kind of strange segue for us to be taking. However, I have found that forms are one of the most difficult things to understand, and truthfully, one of the most difficult things to use in React. If someone were to ask me what I think is one of React's greatest weaknesses, I would probably say forms. Fortunately, there is a plethora of really awesome form libraries out there that, in my experience, many people end up turning to in order to manage forms and not have to build everything that we're about to see and learn about from scratch. However, that being said, it is really important to know how to do this, because especially when you're dealing with a really small form like what we're about to see in the meme generator, it's not that difficult, and once you get enough practice under your belt, it's pretty straightforward. So why are we talking about forms in the first place? Well, in the old days, you would create a form in your HTML and you would give it an action, which had the URL usually of some kind of PHP file that would process your form. You would give it a method, usually of posts, and then when your form was submitted through some sort of submit button, your PHP would pick everything up from there and process the data from the form. Fast forward a little bit to slightly more advanced JavaScript, but still vanilla JavaScript, and you would likely see something that looked kind of like this. This selector goes and gets the form, it adds a submit event listener, and the function that runs whenever the form is submitted would simply gather all the values together and then submit it to an API somehow. Of course, my function is just console logging stuff. If I were to type in a first name and last name here, let's put Joe Schmo, and it's just console logging our data. The main takeaway here, though, is to know that when you're submitting the form, it would gather all the data immediately at the very end of the process and then submit it immediately after gathering it. So how is this different from React? The main difference in React is that instead of waiting until the very end of the process and filling out the form when the form is submitted and then gathering the data, instead what we do is we create state, and every keystroke change or checkbox change or radio button change or whatever it might be, we update state, and therefore we are watching these inputs every keystroke or every change that's made to our form. Then when the time to submit comes, there's no more work really to be done. We already have gathered the data and we simply submit that to our API and pass in the state that we have been tracking all along. Coming up, we are going to jump into the specific syntax of how to do this. However, I really think it would be a good idea to sort of pre-game for these lessons by reading through the React documentation on forms. I know forms can seem like a rather mundane topic, but I promise this documentation from React is really excellent. They've done a great job explaining it. Think of this like reading the textbook before coming to class. Once you've had a chance to at least skim through the documentation and gain some level of understanding on forms in React, you'll be ready to move on to these next lessons where we start learning about how to deal with forms in React. Let's see how we can manage these forms in React, and we're going to start very simple with a single input. I'm keeping this as simple as possible so not to distract us from anything but learning forms. As a reminder, in vanilla JavaScript, we would have a submit button, and when we click that submit button, it would run a function, gather all the data at that time, and then submit it to an API or wherever. What we'll be doing in React instead is maintaining up-to-date state for every change that happens in any input in our form. To accomplish this, there's a few things we need to do. First of all, we need some state to hold the current data that's typed into our input. Just like we've been learning, I can say let's say first name and set first name is equal to react.useState. I will set an empty string as the default because I would expect my input to be an empty input box in the beginning. And now what I need to do is listen for any changes that happen to this input. Can you think what event listener I might need to add to my input to accomplish this? Most or all form elements have an event called onChange, and I can set that equal to a function. Let's call it handleChange, which I obviously haven't declared yet. So let's declare that function. And for now, let's just console log changed. I hit refresh, and now we can see every keystroke that I make is running our function. Now, one thing we haven't spent much time talking about is this parameter that I can actually receive as a part of my event listener function. In this case, I don't get to decide what actually gets passed to my handleChange event listener function. Instead, what will get passed to it by the browser is an event object. This event object is really large. It has a lot of information in it. And if I console log event in Scrimba, it's simply going to put synthetic base event. So at this point, I'd recommend you actually open your developer tools in the browser and see exactly what got logged to the console. You'll be able to dig into all of the properties of this event object. However, there's one property in this event object that I care the most about, and that is one called target. If I log event.target, we'll see that it gives me what Scrimba shows is the HTML element that triggered this event. Now, it looks like HTML in the console down here, but in reality, it's just the DOM object that triggered this event. That DOM object has properties that we care a lot about. For example, the value property. Let me hit refresh, and I'll just start typing letters, and you can see in the console, we're logging the current value on every keystroke of that specific input box. So let me set up a quick challenge for you. Your challenge is to update the first name state on every keystroke. I've set everything else up for you. You should be able to complete this challenge fairly quickly. I've added this console log here. What this will do is every time the first name state changes, it will re-render your component, and therefore it will rerun this console log. This is a really simple way for you to see that everything is working. Assuming you hook everything up correctly in our handleChange function, this console log line should fire every time you type into the input box. Pause now and work on this challenge. Simply enough, we should be able to use the set first name state setter. And in this case, I don't really care what the state used to be, or rather, I don't need to know what the state used to be in order to determine what the state is about to be, because I have quick and easy access to the information that's currently typed into the input box by accessing event.target.value. So I should be able to get rid of these lines. I'll hit refresh, and I'll start typing in my input box, and sure enough, our state is updating with every keystroke. And there we have it. As you can see, at least starting out, this isn't that terribly complicated. However, I am about to throw some wrenches in here. We're going to see that the complexity level will rise a little bit. However, before I do that, I want to get your hands on the keyboard, and we'll do that as part of a challenge. In this challenge, we want to add a last name input to our form. As I've done before, I'm being a bit intentionally vague here, and that's so that I can get you to think of all the steps that you would need to run through in order to get this to work. So do your very best in this challenge, and when you feel like you've got a good solution, you can hit play and I will show you how I would do it. Pause now and work on the challenge. As you worked on this challenge, you might have started to see places where we were not being dry in our code. In other words, we were repeating ourselves quite a bit. For example, I could duplicate this line, and I will change first name to last name. We'll say set last name. I then could duplicate my input, and we'll change this to last name. Now, of course, there's a problem with using the handleChange function on change, and that is because, well, handleChange is only changing the first name. So maybe we make a change that says handle first name change, We'll update our onChange there, and then we'll duplicate this function and handle last name change. You can probably see where I'm going with this and how this is not going to be the ideal solution. And then last of all, we need to change this to set last name. I'll add a console log here just so we can see if things are working the way we expect. We'll look at both the first name and last name. We'll hit save, start typing. We're looking at Joe, Schmo. Okay. Of course, this seems to be working, but we can clearly see this is not ideal, especially when you think of some of maybe the crazy forms that you filled out before that have, let's say, 20 or maybe even upwards of 50 input boxes. It's not going to work great for me to have a separate change function for each one of those and a separate piece of state for each one of those. So next what we'll do is we'll learn how to combine our state into an object and how to use the event parameter that we're receiving in our event handlers to determine which property of that state object we should be updating. So when you feel confident with everything that we've worked on here, let's jump into that next. Let's see how we can improve our form and how we're managing state so that when the time comes to add, let's say 20 or 30 more inputs, we don't end up drowning in duplicated code. Now, if you do just have 2 or 3, maybe even 4 pieces of data in your form that you care about, doing something like this might be okay, or at least manageable. Once you get to 4 or beyond, however, it starts to make a lot more sense to save your state in an object instead of in separate variables. A benefit of doing that is we'll receive one setter function, which we're going to learn how to use to update the correct piece of state in the object. Let's just dive into the syntax to make more sense of this. I'm going to remove this extra function here. Let's change this back to handle change so we can figure out a way to make it more universal, and I'll set my onChange to work for both of those. Let's also get rid of our extra piece of state here, and instead we're going to choose to save an object as our default, and that object will have a first name property as an empty string and a last name property as an empty string. Let's move this onto its own line. Then I'll change first name to something more generic like form data and set form data. Lastly, let's get rid of this so that we don't have broken code. And awesome, this is a good starting place. If you remember back when we talked about the event that we're receiving in our handle change event listener function, if you did spend some time in your developer tools poking around that object and looking at its properties, you probably saw event.target, which we talked about in that previous lesson. Now in Scrimba, if I console log this event.target, it gets a bit truncated to look like an HTML element. However, under the hood, it's really a DOM object that we can access properties on. In fact, we saw how I can look at the value property to get the specific value that was typed into the input box. However, at this point, because an object is what we're saving in state, I can't simply say set form data to event.target.value because that would erase my object and replace it with just a simple string. And because I'm using the same handle change function on both of my inputs, I need a way for the handle change event to distinguish between which input it was that triggered that event. Well, it turns out that a good practice that we're neglecting to do right now is to give each of our inputs a name property. This is true of regular HTML forms in any case, but in React, it's going to play a special role for us. What I can do is make the name property match exactly the property name in the state that we're saving. In fact, a good idea is to just copy and paste it so that you don't misspell it. And now I have access to event.target.name. Let's hit save. I'll trigger the event to happen in the first name property, and you can see it logged the first name property there. If I do it in the last name, it logs last name. Well, this is a great start. We have access to the property of state that we want to change, and we still have access to event.target.value, which is the value that we want to change it to. So now we have everything we need to call set form data and update our object correctly. Let's go ahead and call set form data. Before, when we were simply updating a string, we didn't care about what the previous version of that string was because we were just going to overwrite it with whatever was in the input box. This time around, however, we do need to know what the old version of state was because we have a lot of other properties. Well, in this case, we only have one other property, but imagining a larger form, we have many other properties that we need to maintain instead of just overwrite. So I'll do a callback function in here. I'll use an arrow function and call my previous state, let's say prev form data. I'll use an arrow function and open up the body of that function. My goal is to return a new object, and I want to make sure I keep all of the old object intact. So I'm going to spread out the previous form data, but then I'm going to overwrite the specific property that we are trying to overwrite or that we're trying to update in this handle change event listener. Well, on your first attempt, the inclination might be to try something like, let's use event.target.name as the key and event.target.value as the value. Of course, as we can see in the editor, this is a syntax error. However, with ES6, there was a feature introduced called computed properties. And what this allows me to do is to surround my key here in square brackets. Long story short, it makes it so I can turn a dynamic string like something saved in a variable and use it as the property name for my object. If that doesn't make a whole lot of sense, don't worry too much. Just know that you can fix the syntax problem by having dots here by surrounding it in square brackets. That's an overly simplified way to describe it, but don't worry too much about that. That's not the important part to take away from this lesson. Let me add back my console log so we can look at our state every time it changes. We'll hit save. We can see in the console that it's empty to start with, and as I change the first name, my object is updating correctly. My last name is also still a part of my state. As I update the last name, awesome. This is great news that my entire state is staying intact. Honestly, what we just learned in this lesson might be one of the most difficult parts of understanding forms in React. So for those of you that were able to follow along, awesome, good job. For those that were struggling still, that's completely okay and completely normal. Don't be afraid to go back, rewatch this a few times, and because of that, in the next screencast, we're going to practice this a little bit more. Hopefully in this challenge, you'll get a chance to see why it's beneficial to structure things the way that we just learned how to do.